Welcome to Neon Developer Days. My name is Nikita. I'm CEO at Neon. And today I'm very excited to share our progress towards the mission of becoming the full cloud Postgres. This past few months, since the last Developer Days, we've mostly been focused on fundamentals. Fundamentals such as reliability, fundamentals such as performance, fundamentals such as developer experience and usability. And before I speak more about those features, I want to highlight it's incredible how much Neon has grown. Just when we ran our previous Developer Days, we were at about 60,000 databases under management. And that was just a few months ago. And I'm excited to announce that today we're over 300,000 databases under management on our platforms. A big thanks goes to all of our users, as well as partners such as Replit, Vercel, FL0, Encore, Airplane, Hasura, and many, many more. For those who are interested in how to become partners of Neon, go to neon.tech/partners. And now onto the features. One of the biggest improvements of this release and a flagship feature is our faster cold starts. Neon says database is just a URL. And when the database is just a URL, you would expect it not costing you anything if you're not sending traffic to that URL. This means that we need to scale up based on the traffic and down all the way to zero and not spend any compute if the database is not in use. Unfortunately, this introduces an issue of a cold starts. What if a query comes in? How long does it take for the database to spin back up and start running this query? In the past, our performance of a cold start was roughly about 4 seconds. And I'm excited to announce that today, Neon is sub 200 millisecond cold start, which makes it almost indistinguishable from the database being always up, but you still reap all the benefits of scaling to zero. Our second performance improvement goes to the serverless driver. So let me give you a little bit of background. So typically when you connect to a Postgres database, you're using a standard client that connects to the database over the TCP/IP protocol. And then the Postgres protocol running on top of TCP/IP is actually quite chatty. What this means is it runs multiple round trips just to establish a connection to Postgres. And that's not such a big deal if your database and your client are deployed in the same data center or on the same machine, because those round trips are relatively short. However, if you're querying the database from your browser or you're querying your database from a serverless environment, there is a distance between your application and your database, and those round trips tend to add up. Neon Serverless Driver allows you to query the database over HTTP, and that gives us the ability to do just one round trip. And with some fancy connection caching, I'm excited to say that we're now allow you to query the database from the edge, from a serverless function in a sub 10 millisecond latency, which I believe is the record for querying cloud databases. Another foundational feature of Neon is read replicas. Now, not only we should be known for being able to scale to zero, we should be known to scaling up and out to support the most demanding workloads. And one of the most foundational features for that is read replicas. Because Neon separated storage and compute, we can create read replicas and run them instantly. And each read replica will also auto-scale. And you can create as many as you would like. So that allows you to scale your read workload really, really wide by creating lots and lots of read replicas, each of which will auto-scale. Neon is a Postgres company, and we want to put our money where the mouth is. So when Postgres 16 got released, 4 days later, it was available on the Neon platform. We also added better support for roles and permissions. Oftentimes, database as a service, cloud databases, lock that feature down on Postgres because it's very hard to deliver on security. And we did the same thing when we just launched Neon because it was easier to turn it on, turn it off than support it. But now you have full control on the roles and permissions inside Postgres on the Neon platform. Finally, I want to mention something exciting that we're working on. Because of all the security improvements, we're working on bringing your own custom extensions on Neon. And that is something that is quite hard to do. We're going to have a technical deep dive by one of the Neon engineers on it. And if you are interested in trying that feature earlier than anybody else, please reach out to support@neon.tech. Very, very soon, Neon is going to be available on AWS Marketplace. It's a major milestone for us, so all the enterprise customers can use their AWS credits to purchase Neon. And now we also working on another hyperscaler, and hopefully we'll be launching that soon. I'll keep it to myself who's another hyperscaler cloud is going to be for Neon, but certainly we will soon announce it with a bang. Finally, I want to say huge thanks to all of our users, all of our partners, and everybody who is tuning in live today. And now I hand it over to Mahmoud. He's going to go deep on all the new Neon features, as well as he's going to bring some of our partners to talk about Neon.
During the past few months, we focused on improving the overall developer experience, as well as make it easier for you to scale your applications. Here's a quick overview of what we'll cover today. The Neon CLI and how it enables you to embed Neon into your workflow, the serverless driver and how you can use it to connect from edge and serverless environments, and finally, read-only read replicas. We'll go over how you can use them to scale your application. The Neon CLI enables you to manage your account's resources. To get started, you can install it using npm by running npm install-g neonctl, or if you're on a Mac, you can use Homebrew and do brew install neonctl. Now, to connect to your Neon account, you will need to first authenticate, and you can do so by running neonctl auth. This command launches a browser window where you can authorize the Neon CLI to access your Neon account. And once you authorize, you'll be able to do pretty much everything that you can do with the console, but from the terminal. You'll be able to manage projects, branches, as well as databases and roles. For example, you can create a new project by running neonctl projects create. And as you can see, a project is created, and we also have the connection string, so we can use it right away, straight from the terminal, without needing to go to the console, which is awesome. Now, typically you would want to create a new Neon branch when developing a new feature. And you can easily do it using the CLI by running neonctl branches create, and if you want to specify a name, you can pass a name, and for example, I want to call it dev. And as you can see, the branch was created, we have the connection string, and this connection string is different than the one above. Now, if you actually have multiple branches and you want to fetch the connection string of a specific branch, you can use the connection string command. So you can do neonctl cs, which is a shorthand for connection string, and then the name of the branch. So if I want the connection string of the dev branch, I can just say dev. And as you can see, we have the same connection string as the branch that we just created previously. Now, the Neon CLI is not only useful when developing locally, you can include it in your CI/CD pipeline to manage Neon resources. For example, here I have a GitHub action that runs every time we open a pull request, and this action creates a preview deployment. And if you're unfamiliar with this pattern, it's where you create a production-like environment for every pull request. And part of this flow, we actually want to create a Neon branch for every preview. And we can use the CLI to do this. So this job, it's called deploy preview, has several steps. We check out into the repo, we get the branch name of the pull request, and we'll use it to name the Neon branch we'll create later. We install the Neon CLI, then we create a Neon branch using the pull request's name. And if this branch already exists, then this command will fail, but we'll continue. And we'll get the Neon branch ID. So we need the branch ID, so we actually display the URL of the branch like in the comment. So this will be the URL that will point to the Neon console, and we'll show an example toward the end. And then I run migrations on the specific branch, so you can test changes in isolation. Here I'm using the neonctl connection string command to set the connection string, and I'm using Prisma to run migrations, but you can swap out Prisma with any other ORM that you use. And then I am creating a preview deployment using Vercel, but you can swap out Vercel with any other deployment provider as long as they support this preview deployment pattern. And finally, we comment on the pull request and we just show the Vercel preview URL. So then when the pull request is created, we will have a deployment that's created and you'll be able to see the URL as well as the URL of the Neon branch in case you want to configure it or manage this branch in the Neon console. Now let's actually see what this looks like in action. So here I have multiple open pull requests, and if I go to any of them, you'll see that if I scroll down, we have the Vercel preview URL as well as the URL of the Neon branch, which is awesome. So that's actually how you can use the Neon CLI in your workflow whenever you're developing locally or in your CI/CD. Now, let's actually talk about the Neon Serverless driver. The Neon Serverless driver is a low-latency Postgres driver for JavaScript and TypeScript. It allows you to query data from serverless and edge environments like Vercel Edge Functions and Cloudflare Workers where you can't establish a direct TCP connection. And the way the driver overcomes this limitation is that it provides two options to establish a connection. The first one is querying over WebSockets. This option is designed to be a drop-in replacement for Node Postgres, the popular npm PG package you might be already familiar with. And the second option is querying over HTTP, which offers faster response times for single non-interactive transactions. If you have any questions about the serverless driver, feel free to reach out to us on Twitter or in our community at community.neon.tech. And now, let's actually talk about the last thing for today, which is read-only read replicas. Read-only read replicas enable you to segregate read-only work from your production database operations. And it can be applied to a variety of use cases, such as offloading analytics or reporting queries, distributing read requests to achieve higher throughput, providing read-only data access to specific users or applications who do not need write access, so they do not need to modify data, and finally, configuring different CPU and memory resources for each read replica for different users and applications. So you can create as many read replicas as you like, and each replica can have a specific configuration based on your needs. Creating a read replica involves adding a read-only compute endpoint to your branch of choice. So in your project, you'll go to branches and select the branch where you want to add the read-only compute. For me, I'm choosing my main branch because this is the branch I'm using for production. And in the compute section, I'll click on add compute. And I have the option of provisioning a read-only replica, and I can configure the compute size as well as the auto suspend delay. So the duration before the compute scales down to 0 after a certain period of inactivity. So by default, it's 5 minutes, but we can configure this behavior if we like. And we can also configure the size of this read replica. And it uses auto scaling. So I can specify a minimum and a maximum as well. Now, when I click create, let's say I want it to be the smallest size, you'll see that we have a read-only replica. This has a different compute endpoint ID, so this is completely isolated from the primary read-write endpoint. And if I click connect, you'll see I have the connection string. It supports connection pooling, which is fantastic. Now, the reason this operation is so fast is because Neon separates storage and compute. So whenever you create a new read-only compute endpoint, you don't actually duplicate any data. So that's why this process is both fast and cost-effective. And that's it. These were some of our latest updates. We'd love to know what you think and if there's anything we can do to improve. And now let's get into the rest of Neon Developer Days. We have exciting talks from Neon engineers as well as our partners. So you should absolutely stick around. And with that, thank you so much for tuning in and enjoy the rest of the event.
Hello everyone, welcome to Neon Dev Days. My name is Anastasia Lubennikova, and in this presentation I would like to introduce a new mechanism that enables support of custom Postgres extensions within Neon Postgres. This is a new feature that allows us to support different kinds of extensions, iterate faster, and improve performance and security of Neon computes. Firstly, I'll talk about Postgres extensions, how they work and how to use them. Then I will discuss some challenges of supporting Postgres extensions in the cloud environment. And after this, I will explain how we solve these issues with our new feature. I will tell you how this feature works and what benefits it brings to our development process and to our customers. Let's start from the beginning. What are Postgres extensions? They are add-on modules that enhance the functionality of Postgres. You can think of them as libraries of the programming language or as browser plugins. There is more than 1,000 of Postgres extensions, and they are a vital part of Postgres ecosystem, one of the most loved features. Extensions allow to tailor Postgres to different use cases. They provide functions to work with encryption and AI, with time series and geospatial data. They can turn Postgres into a graph database or analytical database. Some companies also develop custom private extensions to bring business logic closer to the data. Apart from several extensions that are distributed with Postgres, they are supported by third parties. This means several things. Firstly, they do not follow Postgres development schedule, which is only one major release per year. And extension developers can iterate faster, while Postgres core remains lightweight and very stable. This also allows developers to commercialize Postgres, because extensions do not have to use Postgres license, which in turn helps to avoid the need for Postgres forks and helps to keep the project together. So, what types of extensions are there? First, and probably the most common use of extensions, is creating a package of SQL objects. Usually, these are data types specific to some business domain, functions, triggers, and so on. And more complex example of database objects are procedural languages, such as Python or PLV8, which are also distributed as Postgres extensions. This type of extension models simplifies installation and version management. They also implement dependency management, making sure that everything works together smoothly. Next up, we have the extensions that enhance Postgres functionality using internal APIs. Such extensions are usually written in C, and they can be really powerful. In extension, one can implement new storage methods, handle volume replication, implement new background jobs, or add configuration parameters. One example of such extension is Neon itself. And there's more. So Postgres extension system doesn't stop at C. You can package extra binaries and shared libraries written in nearly any language that can be compiled into a binary, for example, C++ or Rust. How to install and use extensions? So first of all, if extension uses Postgres internal API, it needs to be built against right major version. Then, to install extension, we need to put files into shared dir and library files into libdir. These paths are platform specific. So on the slide, you can see examples for Ubuntu. Then, you need to connect to Postgres and run create extension command in each database. Postgres will search for extension files in the directories I mentioned above and will run extension installation scripts. Additionally, some low-level extensions that require access to Postgres memory or, for example, log management system may require library preloading. For them, one needs to adjust config in PostgreSQL-conf file and add library name to shared preload library setting. This change requires Postgres restart. Let's now move to challenges of supporting Postgres extensions in the cloud. As you already know, Neon is a serverless Postgres, And from technical perspective, it means that Neon computes run as Kubernetes pods or VMs, and they scale down to 0 when there is no load. Another fact that is important for us today is that compute images are open source and built in an open repo. As of today, Neon already supports 88 most useful extensions, and you can find the list in the documentation. Some extensions are not supported because of serverless nature of Neon computes. For example, PG cron scheduler and extensions that require file storage to be persistent across compute restarts. So, the trivial way to support extensions is to simply bake all extension files into the compute image. But there are certain drawbacks that come with this solution. First, large size of the image impacts performance, and especially cold starts of Neon computes. Then, there is a need to update whole compute image every time any extension is updated. This requires new release and Postgres restart, which is not very convenient. Also, with this approach, there is no way to support closed source extensions because compute images are open source. And last but not least are security concerns. So the more extensions we put into the image, the larger becomes potential attack surface, even if not all Postgres users need all extensions. At Neon, we solved all these issues by introducing dynamic extension loading. The architecture of this feature is on the slide. The idea is to build extensions in a separate repository and push resulting files into S3 bucket instead of including them in the compute image. Then we can configure a list of supported extensions for each user in Neon control plane. When compute starts, it checks for supported extensions and downloads control files into compute. This operation is fast because control files are usually very small. And after that, compute works as usual. It will download extension library files on demand, only when extension functions are used. That's it. Dynamic extension loading solves most of the problems I listed above. Smaller size of compute images leads to better performance and security. We can now configure extension support per user, which means that we can test new extensions without impacting all user compute. And also we can support custom closed source extensions that implement some business logic specific to customer applications. With this mechanism, new extensions can be installed without compute restarts, which allows us to reduce maintenance time and try new ideas faster. Currently, this feature is in technical preview. We are testing it and going to make it generally available very soon. Stay tuned and thank you for your attention.
Hi there. Today I'll be talking about Prisma and Neon's serverless driver. On the edge is in brackets for a special reason, but please bear with me, I'll disclose more information on that towards the end of the talk. So who am I? My name is Alex, and I'm a developer advocate at Prisma. And Prisma is a small startup that's based out of Berlin that builds tools that make working with databases easier for developers. Prisma provides tools that satisfy 3 specific workflows, which are data modeling, schema migrations, and querying your database. The talk today will be split into 4 segments. In the first segment, I'll give a quick primer on what serverless and edge environments are and the pitfalls that you might run into when working with traditional databases. And then in the second segment, I'll talk about how exactly we can solve this challenge with connection pooling, and then discuss how exactly Prisma and Neon fit together with something that they built called the serverless database driver. And then once with all that, I'll wrap up and share with you a glimpse as to what exactly is on the roadmap and what you can expect from Prisma and Neon, or specifically Prisma. So let's dive in. Now, in case you're unfamiliar with serverless or edge, serverless is a computing paradigm that provides a pay for what you use model. And edge, on the other hand, is like a subset of serverless in that it allows you to run your application even significantly closer to your users, meaning it's distributed all over the globe. Now, suppose that you build your next startup, and on a normal average day, your application receives, say, 20 requests that are running concurrently, and your database has a limit of 20 connections. In this particular case, your database would be able to handle this traffic pretty well, right? But what happens when it's Black Friday and everyone wants to buy everything that's on sale, which is probably everything, and you have 1,000 connections or 1,000 requests at any given point in time? Well, if your database still has a connection limit of 20, then you might start seeing requests failing, and unfortunately, this might lead to a bad user experience for your users. And I won't go in depth into all the different challenges and how exactly you can overcome them, but I would recommend you to give this article a read on the different ways that you can overcome these challenges. But for this talk specifically, I'll cover how we can solve it using connection pooling. One primary way, one idea of how exactly you can solve this is using an external connection pooler such as PG Bouncer or Accelerate. And this would be a separate piece of infrastructure that perhaps would run alongside your database or next to your database. And then it would take away the burden of having to think about the different connections, because it would handle that for you. Another way, Neon, by the way, comes with its own connection pooler that uses PG Bouncer that you can use. Now, I'll give a quick pause here and talk about how exactly connection pooling works. So when your application makes a request to the database, your application would likely use a TCP connection when executing the query against your database. And this has worked fine, but sometimes TCP connections are usually pretty expensive when it comes to managing them in serverless and edge. Now, Neon rethought this whole thing, and they just shifted the game by asking ourselves, perhaps, what if we used a different protocol other than TCP, right? And that's exactly what they did. They built a database driver that uses WebSocket connection. So in the event that your application would receive a request, your application would now use the database driver that Neon offers would open a WebSocket connection to Neon, which goes through a database, through a proxy, which eventually forwards the request through a pool, the connection pooler, and then the database, and then eventually fulfilling the request. And this is great because, again, this takes away the burden of having to, say, provision an extra piece of infrastructure or just worry about TCP connections in your application. And if you're using Prisma, you might be asking yourself, how exactly can I use the Neon database driver and Prisma together? Because they're great. Prisma provides great type safety when querying a database, and Neon serverless driver offloads the whole connection pooling problem for you. Well, we've been exploring this subject for a couple months, and we shipped something a few weeks ago that we are really excited to share with you. And it's called driver adapters, and it's currently in preview. So this would mean that you would be able to bring your own database driver, such as Neon's serverless driver, and then using an adapter, the adapter would now act as the piece that glues together Prisma client, and then the database driver would execute the query against your application. So for a little context, Prisma comes with a component that's called the query engine. And what the query engine does is receive a query from TypeScript land or JavaScript land, and then it converts this TypeScript query into SQL. And other than converting the query to SQL, it also manages a connection pool for you, and it also ships with its own database driver for the provider that you're using. So as part of our exploration, we kind of took these pieces apart, where instead of Prisma having to use the database driver that it ships with by default, you can now kind of plug in whatever database driver that you use. And the query engine would now would only be responsible for generating a SQL query and then sending it over to the database driver that you're using with the adapter that we built. And then the adapter would now execute it against your database and handle the connection pooling for you. And the image that we have here is exactly what it would look like if you're using Neon's database driver. So, and how exactly would this look like in your application? Well, not that much different. You would first start by importing Neon's database serverless driver, and then import the adapter for Neon that we built, Prisma client, and WebSockets, which Neon would use. And then after that, you would define a new configure Neon to use the WebSocket package that we just imported and configure your database connection string. And then after that, you would initialize the connection pooler from Neon, the adapter to use the connection pooler that we're using, and then Prisma client and also by passing the adapter that we now use. And then with that, that's it. You would continue using Prisma client in your application as you normally would, with full type safety and no compromise on the whole development experience. And this currently works, and it works in serverless environments. And what's coming next for us is adding support for edge environments. And this is something that we're looking into, and we're hoping to share something with you in the next few weeks, because we're excited, and this is something that has been long awaited. And in case you're interested in sharing your feedback or trying out whatever we ship out before an actual release, we are running a survey that would ask for a few details from you, which is the database and database provider you're using, as well as the edge deployment provider that you're using. We'd also ask you for your email so that we can share with you details on how exactly you can get started the moment we have something that we can share with you to try out in your application. Besides that, we're also improving the whole development experience when working with Neon and Prisma. And a few months ago, we shipped an extension that allows you to use Neon's read replicas. And read replicas are great because they allow you to distribute high traffic workloads across the different database replicas, and it comes as an extension. So in case you're curious and are interested, we hope that you can try it out and let us know exactly what you think. So what are the takeaways from this talk? Well, at the beginning, we took a look at the challenge that exists when working with databases in serverless and edge environments. And then we took a look at exactly how you can solve it with connection pullers and with Neon, and then took a glimpse at exactly how this could be solved and how it could be integrated with Prisma, and would encourage you to try it out just for your feedback so that we can ship this and make it generally available. With that, thank you for attending the talk. Thank you to Neon for providing me the opportunity to share with you the exciting things that you're working on at Prisma, and I hope you enjoy the rest of the conference. Ciao.
Hello, everyone, and good morning, good afternoon, or good evening, depending on where you're tuning in from. My name is Jacob Lee, and I'm a software engineer at LangChain. I'm excited to be presenting at Neon Developer Days, and I'll be talking a bit about querying Postgres databases with natural language. And a quick aside before I get started. If you're not already familiar with LangChain, we make it easy to build context-aware reasoning applications. And more concretely, you can think of what LangChain offers as a 4-layer cake that helps you create and deploy large language model-powered applications. We're most well known for open source libraries of models such as document loaders, vector stores, prompts, and LLM wrappers that provide common interfaces for various tasks around orchestration. These pieces parse, format, and retrieve data from various sources to present as context to an LLM. Our open source frameworks, available in JavaScript and Python, also include useful ways of prompting and chaining different model calls together, hence the name, to build sophisticated and powerful applications using expression language. And finally, we provide tools such as LangSmith that help debug and evaluate LLM apps, tools such as LangServe that help with pushing apps to production, as well as various templates that show off LLM use cases that you can apply to your own projects. So, first off, a bit of framing. Why do we want to query SQL with natural language? Well, though most of you are probably quite familiar with writing queries, SQL is still a skill that takes some time to learn, particularly as queries become more complex. Furthermore, people who do know basic SQL in your organization might know a bit generally about what your database contains, but may not always be familiar with the specific fields and schema in your particular database. So empowering non-analysts to have some insights into data that's behind this knowledge threshold has the potential to save engineers and data scientists time in creating complex and bespoke dashboards. And given many popular LLMs already have SQL queries in their training data, we have some powerful tools ready-made to make it work. So our strategy will be to use a form of retrieval augmented generation, or RAG for short. RAG is a general technique for guiding LLM generations. If you think of a continuum where on one end you have pure retrieval, like going into Google and querying for data, or manually writing a SQL query, and on the other end you have pure generation via LLM, which would be the equivalent of opening ChatGPT and simply asking for the data you need. Retrieval augmented generation sits in the middle, where you take the best of both worlds and take data related to your query, pass it to the LLM to give it context on your unique task and situation. Specifically for SQL, you might start with a question like, who works here? You could find the answer by querying your database, but this requires SQL knowledge, schema knowledge, and some formatting at the end to make it presentable to an end user. They're not going to want to parse through rows. Our task then for allowing natural language interactions with our SQL database is twofold. We first need to find a way to map a natural language input, like who works here, to a SQL query that will return the correct information. And second, we need to pass the queried rows into an LLM to synthesize as a final natural language output to the user. The latter part is somewhat simpler, so we'll mostly be focusing on the first part of the problem, generating a SQL query via LLM. So now that we've identified the problem, where do we begin? And, well, as everyone knows, LLMs are magic and can do literally anything. So why not try straight up asking the LLM and directly prompting it with, generate me a Postgres query that finds the first and last names of everyone who works here. And the result is actually surprisingly not too bad. However, it did assume that the table name was employees with the trailing S, while our sample database, the popular Chinook demo database, has a table called employee, singular. This is an understandable mistake, given that we haven't told the LLM anything about our database schema. And there's also a bunch of other output that we'll need to parse out at the end. That's to find the first and last names of everyone, etc., and the trailing bit where it's this query selects the first and last name, etc. We just want the query itself. So let's take a look at how we solve the first problem. As I mentioned earlier, LLMs are trained on a large set of data, including code and SQL queries, so they already have Postgres syntax internalized, which is quite helpful since we don't need to explain to the LLM how to craft a Postgres query. And then Raj Kumar et al. Discovered that actually pretending to create each relevant table with literal create table syntax, and then giving an example of some rows using a small select query, generally similar to few-shotting, a technique called few-shotting rather, gives noticeably boosted performance over other methods, such as just directly pasting your raw schema to the prompt. And for the second problem, formatting our output, we use a neat trick. We ask the LLM to structure its output in a format that actually doesn't have the query as the last step. And then we pass SQL result, the next token in the output that we'd expect, as something called a stop sequence that, as the name implies, flags to the LLM to stop generating once it would have generated that given token. We then end our prompt with the beginning of the output structure we requested. The reason this works is that LLMs, even those tuned to chat settings, such as the famous GPT-4, are essentially fancy prediction engines that pick the most likely next token given the context. By ending our prompt with the start of the output structure, we hint to the LLM that it should complete the next line, which we have already told it should be SQL query earlier in our prompt, followed by a generated SQL query. After generating the query, it will try to generate the token's SQL result. But since we've passed that as a stop sequence, the LLM will halt there, and we can extract just the generated query. Though chat models can do this, I've chosen to use a text prediction variant of GPT 3.5 Turbo called GPT 3.5 Turbo Instruct that is more tuned to this style of prompting. So, putting it all together, we end up with the following prompt. I've added a few more lines to try to guard against large outputs and hallucinations, and you can check out the prompt and pull it for yourself from the LangChain Prompt Hub using the link at the bottom of the slide. And there's actually one more piece to call out about the prompt, and that's the initial line. You are a Postgres expert. Though it sounds a bit silly, this actually has a noticeable impact on the quality of the final generation. And to understand this intuitively, LLMs are trained on the sum of all human knowledge, including very bad SQL writing blog posts. Including a line at the start of this prompt, at the start of your prompt, keys the LLM onto the good parts of its training data set that you do want to use, like the parts that know how to write good Postgres queries. It's a simple trick, but one worth highlighting. All right, great. We've got a way to generate our SQL query. Now, of course, our next step is to run it. And given that many of you in the audience are probably experienced SQL developers, if you didn't have an immediate, visceral reaction to that statement, I'm very, very disappointed in you. Now, depending on what you're building, you may not have control over the questions your end user will ask your app. Think of it like sanitizing inputs, except the entire query is, in fact, your input. And you should expect and guard against the LLM generating queries like drop tables or update customers, set email, you stink at smelly.com. And you should use as much caution as you possibly can. Setting a special role for LLM queries and strongly considering making it read-only is a great start, as that way you'll guard against dangerous mutations or deletions. And going further and restricting that role to specific tables is also good practice, since the LLM could have a lucky hallucination and guess a sensitive table or field name, even if you don't pass it in as context schema. You might also consider using a separate database or branch to ensure that if large queries do get generated, they don't excessively consume resources from critical prod flows. If you do need to allow insert, update, or delete access, make sure you set your permissions carefully and don't just allow inputs or deletions to arbitrary tables. And finally, though it's out of scope for this talk, you could also try to do analysis of generated queries before running them on the database. Okay, so hopefully that scared you a little bit, but not too much. After all, this is still pretty cool. So the final piece of query generation I can talk about is using a lower level OpenAI parameter called logit bias. And basically, inputs the LLM are encoded and are then processed as tokens. It's a bit more technical, but OpenAI actually allows you to manually tune the frequencies of those specific tokens. Negative 100 values never appear, while passing a value of 100 makes the token exclusively appears. Not terribly useful. And one other thing to watch out for here is that tokens are actually case sensitive. So something like the with a capital T will actually tokenize differently from the with a lowercase t. Now here's a concrete example of how this can be useful. With the sample Chinook database I prepared for the demo app, asking, what are some good movies? We'll surprisingly restrict outputted movies to the action and adventure categories, as you can see in the generated SQL below. There's a join there, and you wouldn't expect it to necessarily only generate action and adventure movies, but it seems like that's what the LLM and feels are good movies. And it's, again, hallucinations, arbitrary, anything can happen or be generated here. Adding a positive bias towards the token drama will make the LLM generate a query that filters on drama, while still allowing more specific queries that you'd actually want different categories. So what are some good action movies, for example, would still work and generate good outcomes and good queries there. And a word of caution here. While this is an interesting tool in your kit, it's best not to treat it as a substitute for security measures and only use it for nudging outputs. So for example, tokens are case sensitive, and as I mentioned earlier, and furthermore, putting a space before most words will cause them to tokenize differently. you can see in the example to the right that I've put delete twice in caps and lowercase delete once, and resulted in 3 different tokens. So while you might think you're safe by passing capital delete as a forbidden token, the LLM could still generate space delete or some case insensitive version, such as capital D, all lowercase delete. And given an input that asks it to drop tables or delete from a table, the bias is already so strong for the LLM to generate a query with that token that it's just not reliable to ban specific SQL behavior. It'll try to find a way around it or generate nonsense in the best case. So you should think of logit bias as a similar spirit to prompting in that it'll guide the LLM's output and ideally generate better outputs for tokens you do want, but relying on it as a single measure to ban bad behavior is a losing battle. Okay, and now I've prepared a demo app built on a NeonDB hosted version of the popular Chinook demo database, which mocks a digital media store and has tables for artists, albums, media tracks, invoices, and customers. It's hosted live as a Vercel Next.js app, and I'll go through it a little bit right now. Okay, so switching to Chrome here, I have a talk to SQL with LangChain.js app hosted on Vercel. It's actually querying a serverless NeonDB Postgres instance running the Chinook demo database behind the scenes. And again, that's the database simulating a media record store with various tables for artists, albums, media tracks, invoices, customers. So let's just try querying something. Who works here? As you saw earlier, there's already an employee table, so I'd expect some kind of select query that looks over employees. And let's see, generated a query that looks pretty much what I expect. The employees who work here are Andrew Adams, Nancy Edwards, Jane Peacock, Margaret Park, etc. And I can actually go into LangSmith and see what this trace looks like. So I'll go in now. And I can see that, yeah, this is what I expect. The outputs I saw from the app there. But I do see 1 or 2 interesting things. First of all, it did ignore the query for most 5 results using the limit clause as per Postgres here. Example of how you can't necessarily exclusively rely on prompting, even though it can be helpful for guiding outputs. You can't exclusively rely on prompting to prevent bad outputs or bad queries in this case. But you can see the rest of the prompt, the expert prompting, which I showed off here. You are a Postgres expert, which is quite helpful. Some of the tables that are few shotted in. So create table, public actor, exactly how you create the table if you're generating it yourself. And yeah, if you shot it with select queries and then scrolling down farther, there's quite a lot of information here. In production, you may not want to give it, you may not even want to pass all these tables in as context, but just for the demo purposes, so we can sort of show everything, I'm doing it here. And then you can see the SQL query that gets generated. Cool. So this is a very simple example. Let's try a more complicated one. So I think I showed earlier, there's no chat history for this, by the way, yet, but should theoretically be possible with smart prompting. And I could try something like, what movies are good? And let's see what happens. So it's going to go through all the steps, generate. And yeah, I see the movies Airplane Sierra, Amadeus Holy, American Circus, etc. are good options to watch as action or comedy. I guess the LLM has its own concept of taste, but you can see it does actually an inner join on category and looks specifically for action or comedy movies, which is kind of cool. And it does, in this case, get the limit as 5. So yeah, let's look at this in LangSmith. I'll go back to my dashboard here. I can see the new query here. And yeah, I can see, again, same prompt here and the outputted query below, which is exactly what I saw in the initial database, or sorry, the initial output from the app there. So I think one thing to call out here is perhaps, let's say, okay, it's a little bit weird that, the only good movies are not, there are good movies outside of action or comedy movies. So let's say, yeah, we want to figure out why it's only generating action in comedy movies. And I think a common first step for this is to edit the prompt and update it so that the LLM is more inclined to generate maybe movies from other categories. So I can actually go into, LangSmith has a playground feature where you can actually go in and look at the prompts that sparked and kicked off specific runs. So I can see exactly the same prompt I saw before. You can see the model I used to generate, so I could try different models if I wanted to. For now, I'll just stick with GPT 3.5 Turbo Instruct. I can see different parameters and edit them. So temperature is a common one. Higher temperature is more creativity. Too high, as you'll see in a minute there. Get myself out of the way there. You get kind of garbage if you put it all the way up to 2. Yeah, you get kind of craziness. So you don't want to set it too high. I think for generally structured outputs, setting it low is quite a bit more useful. And then you can also see the stop sequence that I previously mentioned. So let's try updating the prompt to say, pay close attention to the movies, or the category of movie you return. You should return mostly drama movies. Cool. And if I run it now, let's see what I get. Okay, cool. So yeah, this time it didn't actually return any category-based movie, but instead rated on PG versus G. So I guess good in this case was taken to mean family-friendly. But how about return? The only good movies are drama movies. Okay, and this time I get, in response to the question, what movies are good, a SQL query that restricts only good movies to drama, category named drama. Cool, so this is an example of how LangSmith can be helpful to tweak prompts and generally get your LLM apps generating what you want them to. The below link has a representative LangSmith trace that allows you to see the various inputs and outputs to each step. The project I looked at earlier wasn't publicly available, but you can go to the link at the bottom of the slide there to go and poke around the various steps and inputs and outputs at your leisure. So LangSmith is currently in open beta, but if you'd like to try it out, you can sign up with langsmith_partner_2023, all lowercase. And that'll let you sign up and immediately start sending traces to projects. And that's it. Thank you very much for listening, and I really hope you enjoyed my talk. If you'd like to keep in touch, you can follow me at Hakubu on X, formerly Twitter, and follow LangChain at LangChain AI for more goodies. I've also included links for both the live demo app, the source code, and all the technologies used in it below. I hope you enjoy the rest of the conference.
Hey everyone, my name is Alex, and I'm here today to tell you about Drizzle. As you might already have known, Drizzle is a weather condition, and by a happy coincidence, it's also one of the most popular TypeScript ORMs on the market. We have 14.5 thousand stars on GitHub and a fantastic 16,000 community on Twitter and Discord. Drizzle's been built by a team of 3 people. We call ourselves Drizzle team, and we love to drizzle, and we are very open about that. We love SQL and we love TypeScript. SQL is not going anywhere. It's only getting better and better day-to-day basis. And TypeScript has an amazing type system for tool makers. So we decided to settle down on TypeScript and SQL, and of course, open source everything. On Twitter, some people speculate that we are a pizza shop. It's completely not true. Don't believe everything you read in Twitter. So what's Drizzle? Let's see what developers say. Drizzle ORM is not an ORM. It's merely a overrated type-safe SQL wrapper, not even a query builder. Well, let's break it down. ORM stands for Object Relational Mapping, and historically, it happened to be that people called ORMs data frameworks like Django and Spring Boot with Hibernate, and we truly believe this is a misconception. ORM stands for Object Relational Mapping, and Drizzle definitely does this for you. And as you can see, Drizzle is definitely a query builder. You cannot be more query buildier than that. This is my favorite one. What I notice is also an understandable API. Text is a text. Primary value is primary key, and so on. I could not agree more. Let's see what this gentleman was talking about. You define SQL schema in TypeScript, and we've specifically designed it to be one-to-one representation of SQL. It's very convenient, and as you see, serial is a serial, and integer is an integer. I mean, you get it, yeah? You get it. Drizzle was definitely not the first one, and apparently not the second one. And sorry, Aaron, we didn't go the easy path, and we built Drizzle our way. So what is Drizzle? We call Drizzle a headless TypeScript ORM with a hat. That might sound a little bit confusing, but we can get into that. Drizzle is just an SQL but better. We let you build your apps the way you want. We don't interfere, and if you know SQL, you know Drizzle. We are the only ORM that is built to be dialect specific. In that sense, Drizzle is very wet because we do repeat ourselves all the time. But this architectural decision let us iterate really fast, and it lets you enjoy dialect-specific stuff like views, schemas, etc. without any kind of trade-offs. We are 100% into your developer experience. You can use Drizzle with any database, in any cloud provider, and Drizzle lives on the edge. Drizzle is fast. Well, it's kind of fast. It's not that Drizzle is fast, SQL is fast. And Drizzle just doesn't slow you down. So when you combine SQL and Drizzle, you get full speed, blazingly fast. And we are the only ORM to expose prepared statements API, which makes things even more blazingly faster. If you are curious, you can visit our website, and we've prepared a proper bunch of benchmarks for you and carefully crafted a beautiful experience. Go check it out. So where is the hat then? Let's see. Drizzle has schema management and automated migrations with our Drizzle Kit CLI. We have relational queries. We have Drizzle Studio, and we have a various bunch of first-class extensions. And all that forms this conclave of beautiful, hatful ORM features. Let's tackle them one by one. Migrations. In Drizzle, as you can see, you define schema in TypeScript, and then you just run a single DrizzleKit command, which is called generate, and it generates you an SQL migration off of that schema. You can change anything you want, you can rename anything, delete, insert, etc. And it will generate everything automatically, and whenever it will not have enough information, it will ask you for. With Drizzle, you can also pull and push to and from the database, and the pull will introspect the database and lay out the schema in TypeScript, and push will apply any kind of changes you have in TypeScript to the SQL database directly, which is insanely useful if you are rapidly prototyping. Relational queries. This is one of my favorites. We call it query plus CRUD. CRUD obviously stands for select, insert, update, and delete. And in Drizzle, we have this beautiful query syntax with which you can query database entities with their relations. And Drizzle will do all the mapping by itself. You don't need to use any kind of joins. And this query API does not have the N+1 problem, because we always generate exactly one query to the database, and is very performant and is very useful when you're using a serverless database, because you will have only one round trip to the database. And the last but not least, the Drizzle Studio, which is we've never intended to build, but the community asked, and we've built it within a month. And as you can see, it definitely evolved since then. And we now have a list of tables. You can truncate and delete them. You can paginate through data. You can export to CSV or JSON. You can hide columns or show them. You can filter, and you can insert, delete, update. And we have a nice JSON viewer. And recently we've added the TypeScript query runner. And as you can see, we show you the result type, and we show you the SQL that is going to be run on the database, and we plot the results in table or the JSON representation, and then you can export everything. This is very useful. That's it. Get on the Drizzle train, and yeah, choo-choo. Thank you.
Good day, everyone, and welcome to the Neon Developer Days event. It is a privilege to be here and share the stage with so many companies and the Neon team, while we take you on an incredible journey of innovation. My name is Kevin Blanco. I am a Senior DevRel Advocate at Appsmith, the best no-code and low-code platform to build enterprise dashboards and internal tools. And today I'm going to show you how together Neon and Appsmith can be a perfect fit for building modern cloud solutions. So let me briefly introduce our amazing platforms and why they are the best choice for businesses and developers. Appsmith is a fully open source platform that empowers technical users to build custom applications on the top of their data. It is designed for developers, business owners, data architects, and all types of engineers, allowing them to quickly create, deploy, and share applications with end users. What makes Appsmith special is its no-code and low-code capabilities, which enables users to build powerful apps without the need for extensive coding skills. So imagine creating internal tools and dashboards with ACE, automating critical business operations and beyond, and making data-driven decisions in minutes. Appsmith has been a game changer for SaaS and enterprise companies, maximizing engineering velocity and minimizing costs. So, if you, like me, enjoy using Neon as your managed multi-cloud serverless Postgres database service that offers separation of storage and compute with features like autoscaling, branching, and bottomless storage, I'm sure you will also love how easy and robust it's to build powerful solutions with Appsmith, making it the go-to platform for enterprises and businesses looking to supercharge their productivity. Whether you are a startup looking for cost-effective data solutions or a large enterprise needing a robust and reliable backend and frontend, Neon and Appsmith have you covered. But today, I'm not here just to talk about the incredible features of Appsmith and Neon. I'm here to show you how they work seamlessly together to create something truly remarkable. I've prepared a demo application that showcases audience intelligence data from a fictional TV network channel, and we are going to build it from scratch, completely from the ground to production in just minutes. So without further ado, let's get started and let's build this with Neon and Appsmith. Alright, here we are ready to start building this demo. We are at the Neon platform right now, in their website, and here I'm going to start building the data structures that I need to build a dashboard that provides insights into our viewership, demonstrating how businesses can leverage this to make data-driven decisions. So let's sign in into Neon. I'm going to use my Google account. I already have an account, but you can create one with GitHub or Google. And then you will land into the projects page. Here I have one project already, but you can create a new project very easily. Then you're going to have certain details about your app, your project. In this case, the connection details, the branches, etc. And on the left, you can control again the branches, tables, settings, integrations, roles, databases, and so on. I'm going to create a new database for this demo. So I'm going to call it demo, and let's hit create, and that's it. Now we have a database ready to start building what we need. Let's go to the SQL editor, and here we can use plain SQL to start creating the structure that we need. So I'm going to remind you that we have a fake TV network. So in order to support what I want, I'm going to create 4 tables. One is for the channels, where we're going to have data about the different channels that we have in our TV network company. Then the TV shows, which is going to store data about the different shows that we display on this TV network, is going to have a relationship also to the channel ID. Then we have the audience. The audience is going to be the people who watches these TV shows. And we're just going to have some basic data. It could be bigger, but for this demo, it's going to be just the name of this audience, their age, their gender, location, and interest. And then we have viewing history. This is like the biggest table that we're going to have in terms of data, because we're going to store everything that the people, in this case, the audience who's watching the TV shows, are doing. And it's just a relationship to a given audience, a given show, watch time, which is how much time they watch certain show, and also channel change count, because I'm going to be tracking how many times people tend to change the TV show as they are watching that show. So what I can do here is run, and let me see what happened here around watch time. Let me see what I did run. I don't know. I just hit run again, and it worked. It's probably a small syntax error here, but there you go. It created the 4 tables in our database. Let's create a new blank query, because now that we have the structure that we need, I'm going to enter data into those databases. To those data tables, sorry. So the first thing is the channel table. We're going to create 5 different channels. One for the entertainment, news, sports, cooking, and kids channel. I'm going to hit run again, hoping that it works fine. Yeah, there you go. It's fine. And now we have channels into our database. Let's create some TV shows now that we have some channels. A new query. And again, very basic SQL. I'm going to insert into TV shows some shows. In this case, for example, How I Met Your DevRel, which is a comedy show, DevRel versus Marketing, a drama show, The Murderer of a DevRel, which is a police show. That sounds interesting. The DevRel News, which is a morning news, and so on and so forth. You know, we have some shows, some genre, some duration and description, and the channel ID, which is the last one here. And once again, there is like a mistake here. Let's see what's going on. It worked perfectly. All right. And that means that now we have channels and shows. Now let's create some audience. For these audiences, they're going to be just pretty much testing audiences. So we're going to generate some random values just for the sake of testing. So let's create a new query. And here we're going to have, we're going to create 50 different audiences where we're going to randomly select their age, randomly select a location from a states from the United States, and a random interest and a random gender. Again, I'm just going to hit run, and now we have test information about our audiences. And now the last thing is we're going to create some viewing history. For these ones, I want to create a lot of records, because that's how we're going to be building an actual dashboard into Appsmith. So here what I'm going to do is, and let me just delete this, is inserting into a viewing history a bunch of viewing history. For each individual shows, I'm going to create around 200 watching histories with random values, random daytime, random channel count, random everything, just for the sake of testing. So let's hit run. And there you go. We inserted a bunch of viewing history. So now we can go to our tables and just make sure that everything is looking good. Here we have audiences. There you go. Some random locations, random gender, random age. We have a lot of viewing history. We enter a bunch of them for different TV shows. We've got our TV shows and our audiences. So it looks like we're ready. We are ready to go to Appsmith and start building our application. So let's do that. All right, let's go to appsmith.com, and here you will be able to create an account if you don't have one, again, with Google or GitHub, or log into your existing account. Also, you will be able to see some information about the company and the product. I encourage you to take a look at, but let's jump right into the actual platform, and I'm going to show you how to build an Appsmith application. So once you log in, like I said, with Google or GitHub, you're going to land into the main screen of Appsmith, which is the workspaces. Workspaces is a mechanism to group different applications that makes sense to group. For example, let's say you have a marketing department and you want to have apps that the marketing department is going to use. Something important is that you can share data sources and certain elements within a workspace. So if you don't want something to be shared across a workspace, it makes sense to create another workspace. You can have as many workspaces as you want. I have a bunch here on the left. So for this example, I'm going to create a new workspace. By default, it's going to have on title as the name and no apps. So here we can create a new application. And once you click there, you will land into the main Appsmith development interface. That's how I like to call it. And you have three main areas. Area on the left is going to be your data sources, your queries, your widgets, and your libraries, like everything you can use in your application. Then on the center, in the main portion, is your canvas. This is where you will drag and drop your components, your UI components, where you will compose queries to your databases, where you will build JavaScript files and custom logic. That's where the magic happens. And then on the right, you have properties of whatever you select on the main screen. So for example, if you select a widget, you will see all of the properties of that widget on the right. So let's start building something to warm up, something very simple so you can sneak peek on how easy it is. Let's create a new data source, and once we click here on new data source, you will see that we have a lot of built-in connectors to multiple data sources out there. And if it's not here, you can always use REST API, authenticated API, if it is a OAuth 2 authentication or whatever API we support. So in this case, since Neon is a Postgres database, we're going to select the Postgres option. And here we need to enter our host, our database name, authentication, etc. Where do we grab that? Very simple. Go back to Neon, and on the dashboard, you will see the connection information. Here we have the host, the database name, the username, and hidden right here is the password. If we click it, you will be able to see the password. So let's copy all of that into Appsmith. First of all, the host address, then the database port is going to be the default one. That's great. The database name, remember we name it demo or demo. And then the username is Kevin, and the password, I have it right here. I don't want it to show you, so you don't use my connection. And then we test the configuration. And there you go. Just like that, Appsmith is now confirming that we can connect to Neon. And now we can give it a name and we can save it. And once we save it, we are able to actually see the data from this data store. In this case, for example, we can see the different tables which we already created and actually sneak peek into the data on those tables. From here, we can do one of two things. First thing is build the page by ourselves. Go to the page, which is empty, and drag and drop some components into the canvas and start connecting and binding the data from the database into the UI. I have custom logic for buttons and JavaScript, etc. That's great, but there's other mechanisms that can really speed up development. If we go to our data source and we pick, for example, in this case, the TV show, let's say that, again, to warm up, I'm going to build a mechanism to control the TV shows for our network. So all I have to do is click this button right here, generate new page. And that will automatically generate a full CRUD application to control our TV shows. So now our canvas have data. Look at that. We have a table showcasing all of our different shows. We can, for example, rearrange the columns here. And once you click, like I said, any of the widgets, you will have the properties on the right. So for example, I click this text field right here and I can change the title. Let's say it's going to be TV shows. And I can change the style. So for example, I can just put whatever font size I want or pick any of the default ones that we have here. So for example, let's say XL. I can change the color, the background color, the formatting, etc. Like you can change literally everything. And if not, if this is a text field, you can also put CSS, like custom CSS, and make it look the way you need. That's amazing. So again, every time you click something on the right, you will see its properties. So for example, we have this table right here, which shows the TV shows, and they are sortable. They are you can filter them for any type of attribute. Let's say name, and then contains, and then I can say DevRel and hit apply, and most of them says DevRel, but there you go. We have filter out of the box, like super simple. And also we have search. You can search for any type of TV shows. Like, this is a powerful component. The table is one of the most powerful components in Appsmith. You can also change like the columns. Like, for example, let's say I don't want to say show ID, but just ID. And that's it. Then we have on the right the form to edit any of those specific items. So every time I click, I'm going to see the data of that specific row on that form. Again, I want to change the title because I don't want to show the ID. I'm just going to say update. And then this is how you bind data in Appsmith. Super simple, double curly brackets. And then you have the entity. In this case, going to be the data of the table. Selected row, in this case, whatever you click on the table, that's going to become the selected row object. And then we have all of the different fields. So for example, here, if I put the dot, I will see all of the different properties of the selected row. I don't want to share the show ID. I want to show the name. So there you go. In this case, whenever you click, now it's going to say updating and the title of the show. In this case, DevRel Masala, or pain of the avocado, etc. And then when we click plus, it's here, the plus button, that's going to bring a mechanism to create a new row, which again, we're going to be able to create a new TV show. Last but not least, we can see that we can delete the records from the database because Appsmith automatically put a delete function. So there you go. Like, in just a couple of clicks, I have a full CRUD application for our TV shows. Let's deploy that, and it's automatically create a actual page. Like, this is the actual app. I can literally share this already. It's not public. I have to invite people, but I can make it public, available for anyone. And here it is. For example, let's change here, instead of UEFA DevRel League, which is going to be a soccer sports, we're going to call it, I don't know, the Libertadores DevRel League. And just like that, we update, and there you go. Now that's the name of that show. So cool. This warm-up is just to, be able to get to know Appsmith, what the different data sources are, how can I access the widgets on the left, what's a query, what's the properties, and I can actually even see the queries that Appsmith created for me, and I can also come here and write my own queries if I want to. So this is the delete query, the insert query, the update query, and the select query. Now let's do something more crazy, which is what we're trying to achieve here with our demo. Let's create a new blank page. I already have the data source connected, so I'm going to create a new query. And this query is just going to call it audience 1. I'm going to get some data from the audience. And here I can just write plain SQL syntax, but let's say that I'm not really good at building SQL syntax. I don't remember. Let's say I don't remember. I can use one of the greatest and latest features from Appsmith. It's called contextual prompt AI. And this is not just a simple like ChatGPT query that you ask something. This actually understands your tables, your data structures, your data fields, and it's actually going to give you something useful in the context of your application. In this case, the database. But if you want to use this powerful AI feature also on the widgets, again, it's going to understand your widgets, what their structure is, etc., and it's going to give you something useful, something actually useful. So to start warming up, I want to just showcase a very simple graph of our audience based upon their gender. I just want to showcase the different gender of my audience, so I can see, how many counts I have in that particular value. So I can just ask AI, hey, I want the gender versus count of audience with that gender, female or male, because that's the records that we have in the database. And just like that, Appsmith is going to scan our database, our data fields, our data structure, and it's going to give something valuable using the actual field names from our database. So we can just use this, give it a run, and there you go. Just like that, we have a count of our audience gender. And then I have two things that I can do. One is use any of the bindings on the right, which is bind the data to a specific widget, or just go to the page and drag and drop the widget and bind it myself. But I'm going to do it the first way because it's easier. I'm going to select chart, and just like that, now we have a chart that is showing real data from our database into the Appsmith app. It's in real time connected. So if we create more records, we will see that in real time showing here. I can change the different things like styles, colors, etc., titles. So I'm just going to call it here audience. And then we have audience gender report. And then I can change the X. In this case, it's going to be gender, and then on the other one is going to be just a amount of people. And there you go. Just like that, we just created something functional and not even knowing anything about SQL. Let's do something even more advanced. Let's create a new query. And again, I'm going to use the power of AI. In this case, I want to showcase the age of our audiences. But since their age is very fluctuant between different values, if we showcase all of the different ages in a chart, it's going to be a lot of different ages because our audience is very broad. So I'm going to do it by range. I want to do it by range. That's what our maybe our boss asked us. So again, let's use the power of contextual AI. I can see recent prompts here, but I'm going to create a new prompt, and I'm going to say, hey, get from the audience table the age versus count of audience with that age, but group the ages by 10 real ranges, like 30 to 40, 40 to 50, 20 to 30, and so on. And again, just like hitting enter, Appsmith is going to go and get the best response based upon our data structures or data fields. And just like that, we should be able to get our response back. So there you go. Now we have the select, all of the ranges or the cases, and the actual table fields. I'm going to use this. I'm going to give it a shot. And there you go. Now we have all of our age ranges and a count of those age ranges from our audiences. And again, let's create a new report here. A new chart. And in this case, I don't want it to be a column chart. I want it to be an area chart. A pie chart. There you go. And I can make this bigger. Again, change the titles and the text. I'm going to say H over here. H and amount. And lastly here also I'm going to change to H, sorry. And there you go. Now we have a chart, an interactive chart, because we can, for example, hover over the different colors and see the values, and also we can filter out. Let's say I just want to show, 20 to 20 versus 80 to 90 and 40, 50. There you go. I can just interact with these different elements. And there you go. Just like that, we just created a dashboard that is showcasing analytical data about our app. Super quick. And not even writing a single piece of code. AI is helping us, and Appsmith is helping us to do all of that. But again, we can customize the way we need. Let's do one more because I'm getting excited here. This is getting so easy. So let's do one with the, remember the channel change count table that we got? The field that we got? So let's do one for that specific. I want to get from the viewing history table using the channel change count. I want to ask it to give me the amount of channel changes per show and pull also the show name from the TV shows table. So in this case, I'm asking data not only from a single table, but from multiple tables. And Appsmith is going to understand this. Again, I hit enter. Like if you're a master in SQL, you can do complex queries here. And if you know your stuff, this is going to be so easy for you. But for people that they're not super active with SQL, that's totally fine. You can leverage the power of AI. So let's use this. Let's give it a shot. Boom. There you go. We just run it. And here we got, for example, DevRel for kids have 411 changes in total count, DevRel versus marketing, etc. Let's connect this to another chart. And I'm going to select another type. In this case, I think I'm going to like not the line. I mean, that's fine. We could do the bar. This is the one that I think it works for this specific case scenario. And I'm going to call it channel change count. Let's call it here change count report. And here we're going to call it, instead of product line, it's going to be amount of changes. And here is going to be the TV show name. And there you go. We just built a full page with different reports, really nice looking, completely responsive, and we're ready to start deploying this. Let's change the name here to reports. And the other one, we're going to call it TV shows, because that's where we were controlling the TV shows. And now we can, again, hit deploy and give it a shot. So there you go. Here it is. We have our reports, and they're pulling the data in real time from the database. And also we can come to our TV shows, which is the page that we built previously where we control all the TV shows, and it's fully working. We have a full app right now working. Oh my God, this is great. So how do I share this? I can just come here and share this with the people that I want. I can also embed either publicly or privately as a business feature that we got, which you can try for free, and also showcase in the Appsmith community in case you want this to become an actual template that people can fork and use. Also, you can make your application public, which is what I'm going to do right now, in case you want to visit it. And let's put a name here. Let's go to Neon. And this is great. So let's say you want to change the branding, you want to change the look and feel. There's multiple ways you can do that. The first thing is we have predefined themes, but you can also define your own theme in the way you want. So you can click on any theme and sneak peek on how it looks. Let's say, I don't know, I don't like this one. This one looks really nice. I'm going to use this predefined theme, but you can also come here and change the font, the colors, the border radius, the shadows, and so many other things about your customization. So you can make this as look and feel at your company branding in this case. So I think there you go. Let's deploy this now with the new theme applied. It's looking really nice. Let's see the reports and see how things are actually changing at the report level, like the colors of the bars, etc. So now we got a real application done. So there you go. I just show you how to connect Neon, how to build a full application, how to use Appsmith data sources, queries, UI widgets, and many other things. And we can go on and on with custom JavaScript logic and so on. But this is just a sneak peek on how easy it is to build a business-ready application that showcases intelligent data from your Neon database. I hope you enjoyed it. That was amazing, right? As you can see, the possibilities are endless when you harness the potential of Appsmith and Neon. Whether you are tracking internal company data or managing critical operations in your enterprise, these platforms are here to supercharge your journey toward success. Thank you for joining us today and witnessing the incredible synergy between Appsmith and Neon. We believe that the future of business intelligence and internal tooling is brighter than ever with these two platforms. I would like to extend my heartfelt thanks to the Neon team for hosting this event and for being such an incredible partner. Together, we are empowering businesses and developers to achieve more with less, and while maintaining complete control and keeping costs in check. If you haven't already, make sure to explore Appsmith and Neon further. Our teams are here to support you on every step on the way. Whether you are a developer, a startup, or an enterprise, we've got the right tools to make your dreams reality. Check out our official documentation at appsmith.com, where you will find Neon's official integration guide, along with tutorials and videos to support you on your journey. Let's change the game together. Thank you again and have a fantastic time exploring the rest of the Neon Developer Days event. Thank you so much, and until the next one.
Hey there, I'm Peter Pistorius, the CEO of Snaplet. We build tools that gives developers really good, production-like data that they can code, test, and debug against. Think of our tooling as a better seed script or a better PG dump for development workflows. Today I'm going to demo how Snaplet's generate functionality works. And by the end of this video, I'm hoping to convince you that it's time to ditch your handwritten seed scripts and move on over to Snaplet. Okay. So Snaplet generates data based on your schema and the entities that you specify in our TypeScript configuration. Over here, I have a schema for a cat cafe in Tokyo where a customer can book a slot to play with a cat. So the customer table has some private information. The cat table has some information about the cat. And the bookings table combines those two things together so that we're able to reference a cat and a customer. What I want to do is insert some information into the bookings table. I currently have no rows. I'm going to specify the intent to generate some data. So I'm going to say Snaplet, I want one booking. I'm then going to run npx snaplet generate -- SQL, and we're going to get some SQL statements that we can insert into our database. You'll see here that Snaplet has inserted a booking, a cat, and a customer, and it's tied it all together. The reason why Snaplet created a cat and a customer is because in the bookings table, those are non-nullable references. So Snaplet understood well enough that it had to go and create those values for you automatically. You'll also notice that in the customer table, we've already generated some data that kind of looks valid. We have an address, we have an email address, and we have a first name and a last name and a phone number. Snaplet was able to pick up what you want to insert into your database based off the structure of your database, the schema. It's not always 100% correct, and in those cases, you can interrupt the data that is generated and specify your own values. I actually want to change this email address so that it is lowercase. So I'm going to say customer. I want to change the email address of the customers that are generated. And what I'm going to do is return a copycat value of email. The copycat library generates deterministic values. For any given input, it'll always produce a static output. That's really important when you want to write tests or you just want stable references to things in your data set. What I can also do is specify a domain. I'm going to use example.org. I'm not comfortable with using anything else. And I'm going to lowercase that. So I can use the full power of TypeScript in order to modify the data that I'm generating. When Snaplet generates a booking and there's a customer involved, modify their email address value to be this very specific copycat.email with a domain of example.org and lowercase that for me. Let's run that again and see if it worked. Okay, so here we got a very specific email address. And it's lowercase and it's at example.org. Now, we said it was deterministic, so I'm going to run that twice. And you'll see every single iteration, we got the same value out. Super, super helpful if you're writing tests. We've generated a single booking. But what if I wanted to generate something like 100 customers, 10 cats, and 1,000 bookings? You can do that too with Snaplet. So what I'm going to do is break this apart. What I want is 10 customers. I'm going to use a new method to generate 10 values. So here I'm saying generate 10 values, and then I can specify how I want that data to be changed. I'm going to say I want that good email address again, and I'm just going to copy this value from here. So now I'm going to generate 10 customers with different email addresses, but they're going to comply to the rule that I wanted to use example.org and be lowercase. And then I'm going to generate some cats. Let's say cats. Again, I'm going to use this C callback, and I'm going to say I want 5 cats. And we're going to modify the data that is generated by this function too. So we're going to say I want their age. Let's just fix the type errors here. I want their age to be within the range of 1 to 20 years. Now, I don't know if you noticed that earlier. I had a type error. So if I try to return a string from here, you'll see we'll get the warning here. That age shouldn't be a type string. It should be a type number. That's because Snaplet understands your schema and it helps you along of generating data that makes sense. And then what we want to do is have some bookings. I'm just going to resize that window here. So I'm going to say what I want is snaplet.booking. I want 1,000 bookings. For the purposes of this demo, I'm just going to make it 100. And then I'm going to add a new value here called autoconnect. What happens here is we're generating 10 customers, we're generating 5, and we're going to pipe these 2 values into this one here, and we're going to auto-connect the relationships. Snaplet will equally distribute the cats and the customers amongst the bookings. So you'll have a representative data set that's equally weighed. I'm going to use snaplet.pipe, and we're going to say, Snaplet, generate these values for me and pipe them together into this into the booking. So I'm going to go ahead and run this. I'm going to generate 100 bookings with 5 cats and 10 customers. Let's have a look at our data. So we have 100 bookings. We have 5 cats and 10 customers.
Now, I made the bold claim that Snaplet's generate is a better seed script. But why is that? We generate data against the schema in your database, which means that we can automate a lot of the tedium that you had to do previously. So you no longer need to maintain hierarchical order of your entities, keep track of IDs, or even specify all the data you want generated. You specify the intent and we'll figure out the rest for you.
Thank you. Head on over to snaplet.dev, install the generate command, and try our tool.
Hey everyone, I'm Jamie, and I'm really excited to be here today to talk to you about Neon with GraphQL. I want to show you something that we've been working on for a while at GraphBase to integrate Postgres and generate instant GraphQL APIs. You can learn more about me and GraphQL at my website, and you can also follow me on Twitter or X or whatever it's called now. My handle is just Barton backwards, no trap. So the biggest problem that we have today is that we use an abundance of different tools. We use so many different tools to power our front-end web, mobile, and wherever else applications. We power these applications with all of the best of breed services. These are really cool. I use so many services to power my own website these days, whether it be a CMS or an image hosting platform for my digital assets, or whether I send notifications via email or Slack or SMS. I use a service for everything and I really like using those. However, all of those documentation styles for using them varies. All of the SDKs are different. Some are better than others. And the learning curve differs between all of these as well. So that's the problem that I think we have today. One problem at least. The next problem is actually fetching data. If I have my content and digital assets all over the place, well, that isn't really efficient to my end user. Now, I'm just talking about my own personal website that's delivering content and videos. But imagine this at a bigger scale. You're fetching content for all of your customers around the world, but depending on which services you use, that data could be in a single region, and that requires then your API to make hops around the world to fetch data wherever it needs. And that really isn't the best way to do things. Now, of course, you could pay all of these individual services money to clone and distribute and replicate your data across the world. However, they often charge you per replica, or you often end up with huge bills from dozens and dozens of services that you use. And that really isn't great. It's going to cost you so much money, right? So what I want to talk to you about, what we're doing at GraphBase to improve this, is by using our caching service. So we're able to write connectors for all of your different data sources, and then you're able to invoke those. And obviously Postgres and Neon is one of those that I want to show you today. We can take that data, create an instant GraphQL API, and then deploy that API to the edge. And then when users query data from that, they fetch that data from the cache instead of going directly to the database. That means you don't need to replicate all of your data and pay all of those costs. So let's dive in a little bit further and figure out how we actually connect all of our different data sources. So here we have some data connectors inside of GraphBase. We have GraphQL, MongoDB, Open API. We can take any Open API specification and automatically generate a GraphQL API. But I want to talk to you today about Neon and Postgres. We have a Postgres adapter that you can use, and then you can insert your URL to your Neon database. Then we can do some magic and introspect what your database looks like, and then we can generate all of the GraphQL queries and mutations to interface with your database. So once you've connected, the next step is to deploy. And as we mentioned before, the edge is really important. We want to make this data available all around the world. So we then need to deploy that. And we've made it really easy with our CLI to run npx graphbase deploy. Once you've deployed this, it is then available to all of your users to query. And we do this using Rust. The whole thing is built with Rust. We then package that up, run that with WebAssembly, and deploy that to the edge with the Cloudflare network. Once we have the API deployed, then we need to query it. So here I have my Neon dashboard, and I have a single table here called users. It has the column ID, name, and email. Then we can see we have a query to fetch all of my users. And you as a user had nothing to do. All you needed to do was connect using the GraphBase Neon or Postgres connector, and we would generate this API for you. So here we can do things like filter, paginate, and even order and sort data from Neon using this instant API that we generated using your connection string. Then we have a mutation, and we don't just have the mutation to create, but we also have mutations to update and delete. And we have the batch variants of those as well. So you can insert, update, and delete many things at once, which I think is really cool. Now, this all sounds and looks cool, but I think we should dive into a demo and have a look and see how all of this works. So here inside of my project, I have a single GraphBase folder. This folder can exist inside of your existing mobile or front-end repo. This folder can contain configuration for your backend. And here we use the connector for Postgres, and we've given this a name of Neon. We've then passed the environment variable neon URL, and we have an env file locally with that value for the connection string there. Then all we need to do to generate this API is to invoke g.dataSource and pass that connector. This then adds Neon as a data source to our GraphQL API. Then we export a single configuration object with our schema, and then we have some defined caching rules to cache all of our queries for 120 seconds. We can also configure things like stale while revalidate, so we can return stale responses while refetching in the background, which is really cool. You can configure these caching rules on a per type basis, so you could choose to cache your users, but if you had another table for posts, you could cache those for less or longer, depending on your use case requirements. With this, we have a GraphQL API automatically generated for us. But what if we want to generate a field or resolve a field using code for a field that doesn't exist in our database? Well, the way that we can do it is by using some code that looks like this. Inside of my configuration for GraphBase, I can say that I want to extend my database user, then we can provide the field gravatar, and then we can specify some input arguments. We can then declare, using the SDK, what this field will return. Here we specified that this field will return a URL, and the resolver is gravatar. Now, if we look inside of the folder resolvers, we have this file, gravatar. This has some default options, and then we're able to abstract the email from the current request, which is the user, and then we're able to run some code to return that gravatar URL. And gravatar is a field that doesn't exist in the database. There is no column for that, but GraphBase will run this code at the edge and resolve that field using the value from the database. So to run this, we can run this locally by running npx graphbase dev. Once this is running, we can head on over to port 4000. This is Pathfinder that's running locally with that GraphQL API that was generated for Neon. Here we have queries to fetch a user by an ID, or we have a query to fetch all of our users in a collection. This collection query has arguments to filter and paginate and order data from your Neon database. We can then loop through all of our different nodes to return the fields that we like. So here we can see that we're returning the ID, name and email, and then this gravatar field. Now gravatar isn't a field in our database, it's actually a remote resolver, or what we call edge resolvers. If I execute this, we can see the data on the right is returned to us. That took a few seconds to return the response, and if I open up the history pane here and scroll to the bottom, we can see that took about 3 seconds by the time it went to the database and returned that data. Now this was a cold boot, it was the first time I ran it, but if I run it again, we can now see that response was returned to us within 3 milliseconds. And that is because of that GraphQL edge caching that we've configured. Now if we switch on over to creating a new user, here I'm going to go ahead and create a new user inside of our database. And here I'll just insert a new user and we'll run that mutation. That then inserts that data inside of our Neon database. So if we go back to Neon and we refresh, we should now see that we have that new user inside of our table user. So that's been a quick look at how we can generate GraphQL APIs for our Neon database. We are really excited for our users to try this out, so if this looks interesting, please join us on Discord and head on over to graphbase.com where you can learn about how you can use this connector. We'd love to hear all of your feedback, so please do let us know, and I hope everyone has a great day here at Neon Developer Days.
Hello everyone and welcome to Neon Developer Days. I hope you're having a great time with us so far. I'm Raouf, I'm Developer Advocate here, and today I'm going to talk to you about how to optimize your developer workflows with Neon database branching. We have a lot to cover, so let's get right into it. The first thing we're going to address is what are Neon database branches? Well, branches are just a copy on write clone of your database that you can use for different purposes. Let's just say that you have a development, a staging, and a production environment in your database infrastructure. So the staging and development environments in this case will just become branches that will inherit schema and data from your production database. You can also use branches for development purposes. So let's say that you and your team are working on features that all bring changes to the database. In order to avoid conflicts, you would like to create different branches that you can give to your developers so they can separately work on those changes without compromising the development environment. Also, here I'm representing Neon as a timeline because Neon knows how to reconstruct your data from any given point in time within your retention period. So you can use also branching to do time travel queries and create a branch from the past that represents the state of your database at a given point in time. Let's start with an example of how you can use Neon in your development workflows, starting by the development environment. So here I have a small application, a small Next.js application that uses Prisma to get data from this atomic element table. And all I do is to display some basic information about those elements in my UI. I'm using Prisma, so I have this schema right here, and I have only one table with 2 properties. The thing is, I don't have a database yet. So one thing that you can do when you're in your development environment, through the terminal, you can use the Neon CLI to create a project and get a connection string that you can use in your project. So the way you do it with the Neon CLI is using the neonctl command. And I'm going to create a project. And this way I can instantly get a connection string within seconds that I can copy and paste and start using in my project. So here I can now move to the right directory in my project and we can then migrate this table here, this atomic table to my database so I can have the table created. And the command is npx prisma migrate dev. This usually takes a minute, But what we want to do is to create this table. But the table is going to be empty, so that's why I have this element.csv file with the list of elements and also their atomic number that we're going to upload in a second. So here I just need to give a name to my migration. I'm going to call it init. And then once it's done, we connect to our database using pSQL to upload the elements.csv file. But before then, I just want to make sure that my migration went right. And I can see that I have my table and my Prisma migrations table also. And we will use the copy command. All I need to specify here is my table and also the path for the elements.csv file. I'm also going to specify the delimiter. So for a CSV file, it's going to be a comma. And also I'm going to say that it has a header. So I'll make sure that this is not considered as a row. All right, so it looks like it worked. And now what I want to do is to run my application to make sure that everything works well. And in Next.js, it's just npm run dev. And I have an error because it's not the right folder. So I'm moving to the right folder, run npm run dev again, and go to my localhost 3000. And the application is working just like expected. So I have all my elements here. All right. So what I want to do now is to add a little bit more functionalities to my small application. So here I want to display the element symbol, and the element symbol for hydrogen would be H, for carbon would be C, etc. So I want to add that. So this change will require a change in my table schema, but also in my UI. And this is why I want to use database branching for that. All right, if I go back to my project, I'm going to quit my pSQL terminal. And what I want to do now is, first of all, I want to create a new GitHub branch. So I'm going to create a new branch that I'm going to call demo. And then I want to create a new property or a new column that I'm going to call symbol in my atomic element. So now what I want to do, I want to migrate these changes into another database so I don't create any conflicts in the current one. And for that, I'm going to use the Neon CLI again to create a new branch that we're going to use for this development. So if I type neon ctl branches create, it will require one more parameter that is called the project ID. And that's the project ID that was given to us when we created a new project. This information can also be found on the console, but sometimes it's just more convenient to find it in the terminal like this. And then I can create a branch, and I get a new Postgres connection string here. Then I can now use for my development purposes. And if I stop and restart the application, then I can see that my data. Let me refresh this page. I can see that my data remained the same because my branch inherited the data and also the schema of the parent branch. All right, now what we do is to use that branch that we just created, modify it, and the whole purpose of using a branch here is not to compromise the main branch. So we have this symbol column that we want to migrate to our table, and for that we're going to use Prisma. Oh, let me write it right. npx Prisma migrate dev, and this way we're just going to add this new column. What I want to do in the meantime also is to add some code in my front end to display that column. So let me go to the page.tsx here, and I'm going to add one more line of code to display the element.symbol. So I'm going to add this h2 here, and let me name this migration add symbol. All right. So once we do this, then Next.js is not going to complain anymore about the symbol because it recognizes it now. Okay. But remember that that it's a new column. It doesn't have any it doesn't have any data. So we have this script right here that is going to add and update the symbol column with the right information. So we're going to run that SQL file. And the way we do this, let me go to the env file, get the connection string. We're going to use psql. So psql, and we're going to execute all the queries that are there. So psql, I'm going to paste my connection string, and I'm going to add -a, -f, and specify the path to the update _symbols.sql. And now it's running all those queries to update my columns. All right, that's good. So I'm going to refresh my page. Oh yeah, that makes sense. I need to restart the app. Let me go to the app, restart npm run dev, and go back to my page and refresh. So now that everything is looking fine, I have my symbol and I have my element here. I'm happy with my feature, so I would like to push all of this to production. But in order to do that, I'll need to create a pull request. And ideally, in a pull request, I'll also create a preview. So for that, I will use Vercel, and I'll point that. So all of that is going to be reflected in our CI/CD pipeline. So we're creating a GitHub action that is going to reflect all of those things. So we're going to create a new branch, perform the migration, and then create the preview, the Vercel preview. So let's go and see how it looks in code. Let me navigate to the GitHub action. So here I have a .github/workflows, and I have this deploy preview, the YAML file, and this runs on pull request. And as you can see, what we do, we create a branch. So we create a branch using the Neon CTL that we previously installed. Then we run the migration before using Vercel to deploy them. So let's now commit all our changes. So I'm going to open my terminal, go to the right terminal, and I'm going to commit all the changes. So first I'll add, I'll use git add dot to add all the changes, and I'm going to create a commit. So git commit, and I'm going to call it demo. All right, so we committed all the changes, and let me push all of that to my GitHub repository. And if we navigate to the repo, we should be able to see all the changes. Okay, I can create a pull request, and I don't want to push everything upstream. I just want to push it to my fork. So, but before creating a pull request, one thing that is important is that we created a new project. And I need to go to my settings here, because if I go back to the code, and let me show you, you'll see that we're using GitHub secrets. And here we're using a new project ID so that I can find here in my terminal, because we created it earlier. It's the same project ID that we used to create the branch. So let me see where it is. Okay, it's right here. All right, let me copy this. And because it's a new project, then I need to add it to my GitHub secrets. And here I can find it under secrets and action, and you can see that I can find my Neon project ID. Let me paste it and update the secret. And now I can safely run the GitHub action and create the pull request. So once the pull request is created, if I go to action, I see that there is an action running, and this will create the branch for me. And once the action finishes, I see that it produces two URLs, so one for the Vercel preview and another one for the Neon branch. So let's navigate to the Neon branch one. Oh, oops, let me get back here. I would like to open it in another tab here. So I get a new branch, and this is the URL for it. As you can see also, the name is demo, and the reason it has a demo name is because the PR that we created was named demo. So here I'm going to my dashboard. I would like to copy my URL. And one thing that I want to do is to do the same thing as before, so uploading the data from the update underscore symbols.sql file to my new database, just to reflect those changes that we made to the database. All right, so the same procedure as before, psql connection string -a-f and update symbol. All right, I'll run this. And I can go and navigate to my preview. And there you go. And these are some of the things that you can integrate into your developer workflows when using database branching. But you're not limited to that. We actually see some creative use of database branching from our customers. We have a few customers that provide multiple branches and multiple states of the same database to their users in order to test some scenarios. For example, they do it for forecasting. So if some elements in the database change, they want to see how that would affect their entire model. Or you could also use it for experimentation. So recently, I wanted to experiment using the HNSW index. If you're familiar with this index, it has two parameters, M and EF construction. And I wanted to know which values provided the best optimal index for me. So instead of creating one index at a time with different values, instead I created multiple branches, and each one of them with different values for M and EF construction parameters. And that allowed me to experiment with multiple scenarios, with multiple branches all at once, see which ones corresponded the best to my data set, and then make a decision based on that. And I could do this using the Neon API. So in this case, I just needed the project ID and also the Neon API key that is provided for you in the Neon console. And with this concludes my presentation. So thanks a lot for watching, and I'll see you guys in the next one.
Hi, I'm Edouard, co-founder of Koyeb, a serverless platform to deploy full-stack apps globally using a simple Git push or pre-built container. In this session, we will showcase how to accelerate backend apps and databases at the edge, combining Koyeb, Neon, and PolyScale. We will use Koyeb to deploy our apps across 6 locations. Koyeb will take care to route traffic from the users through the nearest edge and core location where the app is running. Neon will be used to run our Postgres database. We will deploy it in the Frankfurt region, and we will use PolyScale that will act as a global caching layer to perform reads close to where the application is running to reduce latency. Here you can see the demo that we will deploy in a few minutes, which show how requests flow through the Koyeb network and the latency from each region the app is running to the database and the database cache. All right, let's move forward and start deploying globally. Before starting deploying our application, we'll need to create a new database and configure the PolyScale cache. To do so, on the Koyeb control panel, let's get started by creating a new database service. I click the Create Database Service button here and name my database Neon Dev Days. I keep the default setting to deploy the database in Frankfurt as previously mentioned. The database is being provisioned. Under the hood, we are provisioning a fresh new database on Neon, and in a few seconds, I will be able to retrieve the connection string to connect the database. Okay, here it is. And so with this information, I can now configure the DB cache using PolyScale, which will require some information to access the database. So on the PolyScale control panel, I create a new cache. We'll name it Neon Dev Days. I choose Postgres as the DB type. For the DB host, I retrieve the information from here. And the port is 5432. All right. So we are good, and I get another connection string here, which will allow to connect the database transiting via the PolyScale edge network. So next, I go back on the CoYab control panel, and I will create two secrets. Secrets are a way to securely store sensitive values such as token or connection string. So I will store here the PolyScale DB URL as a secret value. I pass the connection string, and I repeat the same operation for the Neon database. So I grab the connection string here and create another secret, Neon DB URL. All right, so we are good and have everything. So we have the database, which is provisioned and running, the database cache configured and PolyScale, and we can now deploy the application. So to do so, I go back on the control panel landing page and hit the Create App button. The app I will deploy is stored on one of my GitHub repository. Here it is. And let's configure the service. So yes, I will deploy the default branch. I will build the application using the Docker file inside the repository. And to deploy to multiple regions, I will just change the instance size, as on the free one. There is a limit to deploy in only one region. So now I'm able to select all available regions. And last thing is to add the two connection string for Neon and PolyScale that are required by our application. So the name of the environment variable for the new one is pgdb URL, and I'm able to retrieve the secrets I previously created, which will inject the secret value to the application. And I repeat the same with pg-edge URL, which is the URL we will use to connect the PolyScale database. All right, so all the settings looks good. Last thing is to name our apps. The name of the apps is used to generate the public URL to access the application. All right, so we are good, and in a short moment our application will start building. So you can see here that I have the public URL that I will be able to use to access the application, and we see that the application will be provisioned in all those regions. And basically, when the application will be running, when I will hit this domain, I will be automatically routed to the nearest location from me between these 6 locations. So depending where you are in the world, basically you will be routed to, your request will be routed to the nearest regions you are. So the application is building. With our application running, I can now access the public app domain, and I land on our demo application, which is running across 6 locations. So here I'm able to see how requests are flowing from my location to the nearest CoYab core location. You can see that I'm at 27 milliseconds from the Paris core location, and that this core location is to 11 milliseconds from the Neon database and 8 milliseconds from the database cache. If I scroll down, I have the breakdown for each of the regions and their latency to the database and database cache. So basically, when you go to this application, you will see how the request is flowing from your location to the CoYab nearest core location. So depending where you are in the world, you will hit one of those regions. So I hope you enjoyed this demo, and have fun, and see you soon.
Airplane is a developer-centric platform that allows you to build internal apps quickly. In this presentation, we'll show you how we integrate with Neon and how you can leverage that when building tasks. Here, I'm in our IDE, which we call Studio. We have the concept of resources, which represent data sources and integrations, and tasks, which are units of computation that may depend on resources. We recently partnered with Neon to release a new resource type, Airplane Postgres. This enables us to offer a managed database solution, and Neon helps us abstract away a lot of that management complexity. Let's provision a new database through this creation flow. We'll call it internal data for now. The request is sent to Neon, and Neon provides us with a connection string in response. Now that the database has been created, we can put data into it in various ways. You have direct access to the database through the connection string. You can type queries into this management console, and you can also upload a CSV file. For our purposes, I've created a file called leads.csv with some sample data. For the simplest possible out-of-the-box experience, we'll automatically determine the column types for you. As you can see, we've created a leads table. The schema shows up in the schema viewer, and we can also query against the data in the database. The output of the query now shows up here. Now, let's build a couple of tasks against this database. I'll first ask Autopilot, which is our LLM-powered assistant, to build a task that looks up leads by name. This looks pretty good to me, so let's go ahead and apply these changes. We will need to add the query arguments, so let's go ahead and ask Autopilot to do that for us. Cool, let's apply this change now. And let's see if we can run it. We'll first need to make a local copy of this database so that we can work with it in Studio. Neon makes this really easy to do through branching, so we can create this copy very inexpensively. And now let's search for Mark. Alright, looks like we were able to find the name. So yeah, let's quickly run through another example. Let's ask Autopilot to generate another task that adds another lead to the table. Okay, I'll go ahead and click apply twice. So let's do the same thing again. Let's get the SQL query args. Alright, now once this is done printing, we can go ahead and apply this change here. And now we have the query args. And now that we've built our tasks, we can click this deploy button, which makes these tasks available in the UI for other team members to use. So now we've covered the basics of how Airplane works and how we leverage Neon to make it easier for customers to handle data. Thanks for listening in.
Hello everyone, I'm Romaric, CEO and co-founder of Covey. I'm super excited to have you today to show you how you can get full stack preview environments with Covey and Neon. And before we get started, let's jump into the subject. So just before, quickly an explanation of what's Covey. So Covey is an internal developer platform. You might be or not familiar with that concept, but basically we help platform engineering teams inside organizations providing the right experience to the developers to deploy right away their applications and manage like their infrastructure. So just quickly, I will focus during that talk on the preview environment feature. I will explain just after what it is exactly, but what you can just keep in mind is that Covey provides an outstanding developer experience. We really do focus on providing the experience that developers expect at the end of the day to manage their applications and be a bit more autonomous. Covey is a product that you can install on your infrastructure, meaning on Kubernetes and your cloud infrastructure like AWS, GCP, and other in just 30 minutes. You don't need to have like a specific knowledge to benefit from the platform. We do provide out-of-the-box ephemeral environments, preview environments features, so that's what we are going to dig into. And Covey fits perfectly well into your existing technical environments, meaning Git and so on and so forth. So it's a product that is used by more than 100 companies around the world. We have more than 50,000 developers, and you will just see why it's the case after that. But before getting into the details of how preview environments works with Covey, I just want to focus on that part that is when we talk about integrating into an existing environment, meaning it just means that as a developer, you want just to focus on what you do at best, building great applications. You are using existing tools. So Git providers, GitHub, GitLab, Bitbucket. You have maybe a CI/CD pipeline in place. Basically, you can connect Covey to all those elements and right away deploy in your application. I will show you how to manage all of that from the web interface, but we have also other interfaces like a CLI, we have a Terraform provider, and we even have a public API that is accessible, right? So just before, you might be familiar with preview environments or not, but basically what we try to solve with that feature is the ability to spin up to avoid that kind of situation actually. Which is you have many developers that they are working on the same environments, the good old staging environment that is shared across different developers. The more you have people working on that, and the more likely you have to get some issues by sharing that environment. So let's say that Jason has a break that environment because it has released a new feature that is breaking everything. Then everyone is impacted basically, and that's what the preview environments feature solve in some way, is the ability to create and get a dedicated environment, isolated environment for every single features that you are working on. It's a concept that is well known by users that are using Vercel, Netlify, those kind of platforms, even HeroQ. But here, the main advantage and the main concept is that we do manage full stack preview environment, meaning that it's not only the front-end applications that will be created like in another another like dedicated URL, but it's the full environment, meaning that if you have a backend, you have a front end, you have the database, Postgres, for instance, then it's the whole applications that are working all together. So the full environment that will be duplicated into an isolated environment for the time living of that pull request. So here, for instance, if you create a new branch inside, let's say Git, so you have a new branch, you open up a new pull request, what will happen is that Covey will hook that pull request and will create a dedicated preview environment for that pull request. Then from that, it will be isolated. You will be able just to test out this new feature, okay? And this is where Neon also comes by, and I will explain why it does make sense just using Neon with Covery. But basically, you will have a fully dedicated environment for testing out this feature, okay? Once it's done, so you close your pull request, you merge it, then you have validated that everything is working as you do expect. What will happen is that, again, Covery will take care of tearing down and cleaning up all resources allocated for that preview environment. So the backend, frontend, the databases with Neon as well, you will see, will be teared down and just clean up. All the resources will be released, basically, okay? So just quickly, why does it make sense using Covery and Neon? So as I mentioned, you can spin up Postgres, for instance, databases, but any kinds of databases with Covery. The thing is that more than 90% of our users are using Postgres. And one thing that happens is that when you have when you spin up a new environment, you need to have some data inside your database just to test out the feature. And this is where the Neon branching systems comes in. It's really powerful. First, Neon is a serverless solution, so you don't need to have like extra resources just to run the database on your infrastructure, okay? And by using this Neon branching system, what you get is that you can get a full copy of your data from the base Neon instance that is running into another like instance just for the branch. So it's really powerful. That's exactly what I'm going to show you with Covery. And obviously it's 100% compatible with Postgres. So it's a drop-in replacement from your actual Postgres database, and it works perfectly well with Covery. So let me show you that just quickly. So what we are going to do is exactly that. We have defined inside Covery a blueprint environment that you can see here. Okay, so with to-do applications, that is full stack applications, backend and frontend, it's the Java application. And this one will be connected to a Neon instance. Okay, so I assume that you're already a bit familiar with Neon. Okay, so you just need to have an account. I'm using just the free version of Neon, so you will see if you want to play with all of that, you can do it for free. Even Covery, you have a free tier. Okay. And basically, we have like a dedicated URL for that environment. This blueprint environment is our base environment that will be used when we create a new branch. Okay, so when we create a new branch, we'll create a new pull request, and Covery will hook again that pull request and create a new environment for that one. And what you will see is that we will get the data from that instance into this instance, but actually it's a completely fully isolated instance, meaning that all the operations that we make here, so creating new tasks into our application here, will be only reflected for that instance and not for this instance or neither this instance. And we'll create another branch as well, where we'll just change the background. So here we'll have the background in blue, the background in red, and we'll do exactly the same changes. So that's something that is very common for our users, creating multiple environments, testing environments, preview environments for every single features that they are working on. And with Neon, the big value is that you get access to the data from your base instance in no time. That's really good. Meaning that you don't need to seed your database after that's been created. You get it already, all of that for free. So let's jump into Covery now. So as I mentioned, I've defined my blueprint environment. You see, so this blueprint environment is working well. So it has been deployed. We have deployed our Neon Postgres. Our application is even running. So I've tested out this environment. If I open the URL of that one, you see my application is a dedicated URL. My application is running perfectly well. Okay, I can even add new task. This is Neon Dev Days, and you see it's working perfectly well. I'm going to show you just quickly, manually speaking, because we have a feature that we name a clone. Then after that, I will show you with the pull request system. But I can duplicate that environment, okay, in just one click and say that dev days environment. Let's say it's a dev environment. So this environment is a new environment based with the Blueprint environment. So I can just deploy that one, and we'll see that we have a new instance, Neon instance, that will be created. Okay. So just quickly, here inside the Neon, so I'm connected to my Neon. You see, I have my Blueprint instance, database instance that is running. Okay. I can even check the data from that instance, and you see I have exactly all the data, even the data that I've just inserted. This is Neon Dev Database. Okay. What will happen now is, because I'm starting out a new instance, so you see, okay, so, and I'm going to show you how it works because it's very easy. But here what happened is that we have a script that is executed, okay, to spin up the Neon Postgres instance, basically. Because inside Covery, what you can do is that you can put inside your environment any kinds of resources, even scripts that they are going to execute some commands when you execute them to do whatever you want. Here, in that case, what we have done is that we have just defined what we call a lifecycle job, okay? That is just saying that, hey, when you start up this service inside Covery, just execute that script, create a branch.sh. This script I will show you is just composed of a few Neon CTL commands to create the branch based on the base environment that we have. And here, when we delete that service and the environment, the delete branch script will be executed to tear down and clean up the resources from Postgres perspective. You see, so, and the execution order looks like this. Okay, so we have the stage 1 for the database and the to-do app that is in the stage 2. And okay, so if I go back here, oh, you see, my Neon Postgres has been script has been executed, and everything is perfectly done. You see, so here we have our branch, so the DevDays branch that is now created and running perfectly well, and the parent branch is the Blueprint. So if I look this branch, we have exactly the same data, and I'm going to show you that obviously with the application once it's running. So it's building, you see. Okay, so the application has been taken directly from Git. So the new version is in building state. And once it will be ready, we'll be able to play with the applications and change the data. And you will see that it doesn't change the data from the base branch. Okay, so we can wait just a few seconds. Yeah, it takes some time. Just after that, I will show you how you can create the preview environment system. So it's just to illustrate with the action, the manual actions, then you can exactly get what I did. So our application is starting, so it's done. It has been built, so that's great. You see the application is coming from Git, and now is in deployment state. Okay, so we can look at the live logs, and we see that our application is starting now. Okay, so it's starting. Yes. Perfect. So under the hood, what happened is that Covery creates, take care of everything, like creating, so the environment on Kubernetes is the namespace, the network part, the ingress controller, the TLS certificates, exposing the application that has been configured. So we have configured the environment variables, the different elements here, define the port of the application. So if we want to expose, and under the hood, Covery takes care of everything for us. And now we can see that our application is running perfectly well. And what we can do is just basically opening up this link. So we didn't change anything for that one, but actually what I can show you is that if we click here and we have validated that this task has been done, this is another environment. You see, I'm adding the value here. What you see, the value here. So first we have the value from, so the data from the base environment, you see. Okay, but if we go back to our blueprint environment, to the application here, and I open this application, you see that the data has not been modified. They have not been modified from the other instances. That's really like the beauty. And right away, you get access to all of that, which is very, very convenient to test out your new features on real data. That's really powerful. So now, let's say that I want to show you, so because the purpose is like really the preview environments for every single pull request that you're creating, you want to dedicated environment. So how it looks like this, very simple. When you are inside the blueprint environment, what you can do is that you can turn on the preview environment feature. Turning it on means that Covey will start to hook your repositories, and just for every single pull request that you will create, you will have the opportunity to create a new dedicated environment. This is actually something that you can control right from the pull request with the create on demand features that is turned on here. I'm going to show you. So let's say that we are inside our to-do application. Okay, the main branch is the master branch for that repository. Let's say that I want to modify the background. Okay, we want to have a red background. So what we can do is that I can get into my application to do HTML, and actually I can just change those values by the value to get just a red background, a pure red background. Okay, so I can commit the change, create a new branch, and let's say now it's called background. The branch name is background in red. Okay. So update to do for red background. Okay, so I can create that branch, the pull request, hey, this is a new PR. Okay, so look, I created the pull request now. Okay, so the pull request, look, Covery has hooked this repository actually. Okay, you get a message from Covery saying, hey, do you know what? This repository is hooked by Cove. If you want to get a preview environment, you can create a preview environment for that one. No problem. So what I can do is that I can just basically execute. So that's the create on demand feature. I can say that, yes, I want a preview environment and I want to use my blueprint environment as a base environment for that one. So here, I can just click here. I can put that command, so copy paste the command with the UID and just say, hey, I want that environment. And here you see what happened is that Covery is just putting a comment saying that, hey, a new environment has been created, right? So I can go back here. Yes, I have two environments because I have like messed up with like some stuff, but basically you have a new environment that has been created, you see here, with the red background. And that's perfect because if I look at the to-do app, you see the branch here on the right, so I can show you here, is the new branch, background in red, basically. So in a few moments, what will happen is that we'll be able to try out and visualize that the background has changed in the color red with the Neon Postgres instance that is based on the blueprint instance that we have. So the data will still be there, and I will be able to try out this new change with some existing data. You see, so I can check and wait for just a few moments. That one, so you see, again, the script has been built, and now it's in execution. So we can look at that. Yes, that's great. Okay, so if we go back to, you see, that's perfect. We have our blueprint update to do red background here, a branch on on Neon. So we even have the data, so that's great. Okay. And in a few moments, again, like I've just shown before, we'll get our instance of our to-do app with the new version that will be up and running with a dedicated URL. So let's wait just a few moments. So again, we are building the application. So the application is cloned from GitHub. Then it's in building state. Then it will be pushed into the container registry, then deployed on my Kubernetes cluster. The network will be configured, ingress controller, TLS provided, everything connected to the right instance of Postgres on Neon, and then exposed basically. Okay, it takes some time. It's really depending on the application. So here it's a Java application. You see that it's downloading tons of dependencies, Maven dependencies. You can also connect your CI/CD and your container registry. Okay, so if you have a CI/CD in place and you push the container into your container registry, you can just trigger the deployment from that container image directly on Cover. It works well. There's no problem. But here's for the demo purpose. So you see it's exporting the layers from my Docker image and then pushing that into my container registry. So you see, you don't need to be an expert in anything. It just works. It just works. If you want to see exactly what happens under the hood, by the way, Cover is like the engine, deployment engine is open source. It's all explained. You can get like a deeper look on what happens under the hood. So here we are deploying the application. Perfect. By the way, if you have multiple services, so it works with microservices, monorepo as well, you have some optimizations that they are provided. And if you have many services, we have customers that they have dozens, 20, 30 services that are, the components and the services are deployed in parallel. Okay, so there is no problem. So yes, so deployment state. So the container is in starting mode. So it has been deployed now, you see. So we can take a look at the logs. We have access to the logs of the applications, right, from this interface. And it's working well, you see. So we have the green check. And if we open the URL, ta-da! And you see, we even have access to our data. That's great. Perfect. So yeah, that's what I wanted to show you. If we modify, obviously, the data here, so we put them all checked and we go back to our environment, the blueprint one, you will see that nothing has been changed here. That's the beauty. That's the pure beauty of using a Neon, because it's really fast. You get access to the same data as the base environment, and it's really, really convenient to test like the new feature with real data. Okay, so if I go back now, let's say that I want, okay, I validated all of that. That's great. I want just to merge or close the pull request. Let's say that I'm closing the pull request. What will happen? You will see. So now, because I've closed that, you remember, look, the status is changing, delete queued. So now Cover will take care of deleting all the resources. So even the Postgres, so the Neon resources, and the data in the application itself. You see? So we'll see in a few moments. So we can just check and take a look at that. See? Yes. So in a few moments, we'll see a new message saying that the resources has been released. Okay, we can just click here, branches, and you see the branches has already disappeared. So the resources have been released, and that's great. If I want to show you, so that's perfect. It just works perfectly well for the full workflow. If you want to take a deeper look of what looks like the script. So we have written an article explaining all of that, obviously. Okay, you can just take a deeper look. You have access to everything from that. But basically, the script that is executed to spin up a Neon instance is that one. Okay, so it's just Neon commands that are executed, basically. Okay, and same for the deletion of the branch, so the Neon branch. Okay, so super easy. It's all explained. We have an article explaining all of that. Okay, so that's great. So just to summarize all of that, so Covey preview environment is perfectly well for testing out new feature. If you want to avoid like sharing the same staging environment, the same environment across, and your team is growing, then that's perfectly well fitted for that. You can get an isolated environment for every single pull request. By using the Neon Postgres branches system, you can get access to the data from a base instance Neon instance, which is very, very convenient. It avoids you just to seed your database with dumb like data. So to read data, you can be sure that when you merge back your preview environment and you have validated the features that you were working on, then it will work as you do expect, because it will be exactly the same data, but without impacting the base instance. And Neon Postgres is a drop-in replacement of Postgres, so it's coming for free. So if you're already using Postgres, then you can just use Neon. It will just work. One more point is that maybe you're familiar with other terminology. Preview environment is also sometimes called ephemeral environments, dynamic environments. If you're using Vercel, as I mentioned, and Netlify, they call that features deployed preview. The only thing that is changing is that the concept of preview environment, ephemeral environment, is really for full stack based environment, meaning that you have all the services that are inside this environment. Something that I didn't show with Covey is that you can spin up any kind of resources. You can even execute Terraform script if you want to spin up SQS instances, different cloud services, BigQuery or whatever. You can do all of that. It's really made for full stack applications, okay? Which is not the case with deployed preview from Vercel, that they are only focusing on front-end application. Here, you can really deploy any kinds of application. And it's a bit different also from Review App System from Heroku that is based for supporting only one application. Here, you understand that you can deploy as many as you want. You can put as many as you want application inside the same environment. All right. So I hope you enjoyed this talk. If you have any questions, just feel free to reach out. I will be super happy to respond to all your questions. I'm available on X, Twitter, and LinkedIn. And if you want to play by yourself with Covey and Neon, just feel free to register on the playground. It's a free environment that you get. There is no credit card required, just your email, and then you can get access to Covey for free. So I hope you enjoyed this talk, and I wish you a very good day. Bye.
Hello, my name's George, and today I'm going to talk about how we can use NPM packages outside of Node. NPM has lots of useful JavaScript packages. Many of them can be used both within Node.js and on other platforms like Vercel Edge Functions, Cloudflare Workers, or with the help of a bundler like ESBuild or Webpack in web browsers. But some packages assume the presence of Node-specific features like buffer or built-in Node libraries like FS, Path, or Net. These packages can't so easily be run elsewhere. And that shouldn't be a big surprise. NPM is the Node package manager after all, but it can be an annoying roadblock to some things we might want to do. And this is a problem that we faced at Neon. We wanted to make Postgres usable from serverless platforms like Vercel Edge Functions and Cloudflare Workers, but the existing Postgres driver packages all made use of Node-specific features. Some platforms make an effort to help you with this. For example, on Cloudflare Workers, you can add a setting node compat equals true to your Wrangler TOML file, and that makes some effort to provide node-specific functionality. But this doesn't fix every issue, and it's not available everywhere. So in this talk, I'll describe some ways that you can fix this problem for yourself. In other words, how to use NPM packages outside Node.js. There are 5 related techniques, all using examples from the development of Neon's serverless driver, which is adapted from the Node Postgres PG package. All the solutions that we'll cover today have one thing in common, which is that they all use one of my favorite tools, ESBuild, to combine your JS files and dependencies into a single runnable bundle. And if you'd like to refer back to these techniques after the talk, I've also written them up in a blog post at this link. Secondly, today we'll see some of these techniques in action. So what we'll do is set up a Vercel edge function to use the query builder package connects.js to communicate with a Postgres database. And that doesn't work out of the box, so we'll proceed to fix it using some of the techniques that I will by then have shown. So technique number 1, probably the simplest case we'll come across is where a package uses node-specific features that have to be especially imported or required, and there's already an equivalent third-party shim library available. In our serverless driver, events, which provides the event emitter object, falls into that category, for example. Now in this case, all we have to do is npm install the package. So in npm install events, for example. And that third-party package then gets used instead of the built-in node package that was originally intended anytime that the events package is referenced via a require or import. And the final thing that we then need to do is bundle the code using ESBuild. And when we do that, this third-party event support will be included in the bundle. Almost as simple is the situation where a package relies on a global node object, for example, buffer, for which, again, there is a third-party shim library available. And in that case, again, we do an npm install. This time, of course, it's npm install buffer, but we also have to make sure that the shimmed object is always available in the global scope. And it turns out, actually, that ESBuild has a special inject option to support this. So we create a new file, which here I'm going to call shims.js, with the following content. And what we're doing in this 5 lines of JavaScript, firstly, we're checking if there is already a global buffer constructor function. And if there is, then checking whether it has a static alloc unsafe function attached to it. And we need that second test because on some platforms, there's a booby-trapped buffer function that exists only to throw a supposedly helpful error message when you try to use it. Now, if both of those checks succeed, which probably means we're running in Node, we simply export the built-in buffer object on the second to last line there. But if either of those checks fails, then instead we require and export the third-party buffer object instead. Finally, to make sure that this buffer object is present in the global scope for all of the code that we're bundling, we add the inject switch to our ESBuild command, which looks like this. You can see we've added there -- inject and then the name of the file that's going to be injected. We use this same trick to provide our own shims for some other Node built-ins. For example, shims.js in our serverless driver also contains an implementation for Node's process nexttick. And the implementation in our shims.js looks like this. And again here, firstly, we're creating a global process object if there isn't already one available. Then we check whether calling process nexttick throws an error. And if that does throw an error, it could either be because nexttick doesn't exist or because nexttick is one of these booby-trap functions provided by the platform that again just raises an error when we call it. And if it throws anyway for either of those reasons, we attach our own nexttick implementation to the process object. And we do that using a resolved promise, which is about as close as we can get to Node's native nexttick on other platforms. Another common issue is that a package imports a Node.js built-in library that actually isn't really needed. For example, the PG package depends on the PG pass package to read passwords from a .pg pass file in your home directory. And most of the time, and certainly in a serverless environment, almost all of the time, you're not going to need that functionality. But because the PG pass package tries to import the file system package, fs, to read that file, that makes bundling fail if the fs package isn't available, whether or not you're ever going to use that feature. Now, one option here would be to use ESBuild's external option, in this situation. And that option would tell ASBuild not to try to bundle that particular package, and instead to leave a require or import statement in the bundled code. That might work in this case, but depending on how the require or import statements appear in the bundled source code, some cloud platforms will throw errors at upload time when packages that are referenced that way turn out not to be available. So instead, for maximum portability, you can create an empty or stub FS package. And that package could be fully empty, or it could implement some stub functions that throw informative errors if we ever accidentally call them. So a stub package consists of a folder containing just a package.json file and a JavaScript file. For example, in our Neon database serverless package, you'll find a stub fs package in shims fs. And our shims fs package.json file inside that directory looks like this. The key things here are the name and the description. The name has to match the package that we're shimming, and the description may be helpful when people come to look at your code in future. We say that it's a module, and we tell the bundler where to find the entry point with our main key there. And then alongside that, in shims fs, we have a single JavaScript implementation file, and we implement just one stub function, stat, which is called early on by pgpass. And all that does is just inform us that we can't stat because there's no file system. So you can choose whether or not you want to include these sorts of stub functions. You will get an error message either way. If you include some stub functions, then you can make the error messages just a little bit more informative. So once you've created a stub package like this, you need to add it as one of the dependencies in your overall package.json file. And we add it as a local path package, one that uses the file URL protocol. And that looks like this. So you can see there the dependencies object in package.json, and we have added our fs shim in there. And once you've done that, finally, you need to run npm install, and that will copy our shim package inside the node modules folder, where it can be picked up and bundled when we rerun the esbuild command. Now we can use essentially the same technique when a package imports a built-in package and really does need to use it, or at least needs to use some part of it. Happily, it can often be quite straightforward to re-implement or translate functionality in that case. A couple of examples, again drawn from bundling PG as Neon's serverless driver, are string decoder and URL parse. If we take string decoder, it's very straightforward to re-implement this using the text decoder object that's available in browsers and on serverless platforms. So we create a string decoder folder, and inside it we again create a very simple package.json file. Only the name and description have changed here from the previous shim package that we looked at. The name again needs to match the package that we want to shim. And then in the index.js file, so in the JavaScript implementation, the implementation of string decoder is super simple. It just translates string decoder methods to text decoder methods. So at the point that the string decoder is constructed, we just create a text decoder object for use behind the scenes, and then both write and end on string decoder make use of the text decoder's decode method, with or without the streaming option, depending on which one was called. And certainly for the purposes of this example, that's a perfectly sufficient implementation of string decoder. Just like in Technique 4a, it's important not to forget to add the shim package to your overall package.json file. As we can see here, we've added string decoder to the dependencies there. And again, then to run npm install so that the package is copied to the node modules folder. Of course, sometimes you need to use a package that isn't so simple to shim. It could in fact be the whole purpose of the package that you're writing. For instance, the reason that our serverless driver package exists at all is to let you communicate with Postgres even where TCP connections over net.socket are not available. And we make that happen by re-implementing key parts of net.socket using WebSockets as the underlying transport. The principle is just the same one that we saw in Technique 4b just now. It's just that the implementation file is longer. And if you're curious, you can find the implementation file that we use in our driver at this address on GitHub. The last trick I'll discuss today is again a very closely related one, and it allows you to substitute one package for another in a third-party package's dependencies. And I've used this to make my Zapatos package a TypeScript Postgres library, which normally depends on PG, depend on the Neon serverless driver instead. And to make this work, we create a local path package, same as in most of the previous examples, and we name this local path package after the package that we're masquerading as, in this case PG, and in that we simply export the alternative package that we want to be used in its place. So we have this shims PG folder, and inside that we have a package.json file that declares that this is a package called PG, as we can see here. And the pattern here is slightly different to the one that we've seen before, in that I've provided both CommonJS and ESM exports for flexibility in using this shim. And those point respectively to an index.js and an index.mjs file, depending on which one gets used. Those JavaScript files, the JS and MJS ones, are in fact then just one line each. You can see that in the CommonJS index.js file, we just add the serverless driver to the module exports key, and in the ESM file, the .mjs file, we simply export everything from the Neon serverless driver package. And I don't have a slide for it this time, but again, you would need to add this new custom PG package as a local path package to your overall package.json, and again, to run npm install. And you can see this technique in action in an example repo that I've given a link to here, and that's a simple app implemented using Zapatos and Neon's serverless driver on Vercel edge functions. So lastly today, I want to do a little bit of a work through. Let's see how that we can apply these techniques in a real task. And the real task that we're going to do is this. We're going to get the query builder package connects.js working on top of Neon's serverless driver within a Vercel edge function. So let's switch to VS Code now and take a look at the problem here. So this is a really minimal Vercel edge function that we're looking at in VS Code here. It has a public directory. There's nothing useful in that, but we need a public directory with some kind of file in it just to stop the Vercel CLI tool complaining when we run it. So that exists there. There's an API directory with one JavaScript file in it. That will be our edge function API endpoint, and that's just everything kind of bundled into a single file using esbuild. And then alongside that, we have this API source directory, and that has the corresponding not yet bundled source file for the API file that we saw above. Now, within this source API file, we do sort of three separate things really. We start out by just importing connects and the Neon driver in those first three lines. Then we set up connects to use the Neon driver, and we do that by subclassing the standard PG connects driver, but returning Neon's driver rather than PG in that driver function. And then thirdly, the main thing that we do is that we handle any web requests by making a simple database query and returning the result as JSON. And note that we also disconnect from the database here to avoid exhausting our database connections if this gets under heavy load. And by using the wait until method in our Vercel edge function, we're able to do that without holding up the response. So this means that the edge function won't terminate until the connection has been closed, but the response will be sent before that. If we awaited destroy, then we would make the user wait, but by using wait until, we don't make the user wait. Now, to make this an edge function, we need this magic line where we export a config variable. This has to appear quite similar to how it looks here. If this gets bundled by esbuild, it may end up in a format that the Vercel edge function doesn't recognize. So rather than including this in the source, we actually add this exact line at the end of the bundled source as a step in the build process. And we'll see that build process now if we look in the package.json file in this repository. And the package.json file, of course, has our dependencies. So it has the Neon serverless driver and connects there listed as dependencies. And it has the esbuild build command that we're going to use. Of course, we've got esbuild as a dev dependency here to make that work. And there are a number of elements to that, but essentially we're asking esbuild to work on all the JS files in the API source directory, to bundle the files that it encounters there, to put the bundled versions in the API folder. We're asking for the ESM module format. Log limit 0 means that we see all of the logs. 0, in fact, means don't limit the logs at all. so that if there are error messages, we can see all of them. And then, as I mentioned before, we need to add this footer line that makes sure that Vercel treats this as an edge function rather than an old-fashioned serverless function. So what happens when we try and build and run this? Let's open the terminal in VS Code and let's try running npx vercel dev to get a development version up and running. Now I'm expecting that this will create errors because of course there are packages here that are native to Node.js that aren't going to be recognized. Okay, so it's actually telling me that there are 25 errors here, and if we scroll up, I think we'll find that all of these are errors where a particular package can't be resolved. So there's a node native package and it's not available here. Now, just to sort of boil down those 25 errors into which unique package is not found, we can try and grep for that. So npx vercel dev, and we'll look for that phrase could not resolve, and we will then sort and uniqueify that. Now the one thing that I haven't done here is I'm grepping here amongst the standard output, but we in fact need to be grepping among the standard errors. So let me redirect that here. And that should now give us a list of the unique packages that it can't find. Yes, and there are 8 of those packages. Okay, assert, crypto, events, fs, stream, timers, tty, and util, all of which are not able to be found here. Now, you might notice that ESBuild has suggested that we add the platform equals node switch to fix this. That won't help us. That will resolve the errors at build time, but since those packages aren't actually available on Vercel Edge functions, that won't fix the problem. It will just punt it to later on in the process. So 8 packages. Actually, this is not as bad as it looks. Having investigated these a little bit, the 8 break down into 3 categories. The first category are packages that we need, for which there is an implementation already available on NPM. This was technique 1 in the slides that we looked at earlier. And so for those 3 packages, which are assert, events, and util, we just have to install them. So let's do that now. That's done. Very good. Now the second package, the second category of packages, is packages that we don't really need, so that we can just stub them out to suppress errors. And that was the technique 4a that we looked at in the slides. And those packages are crypto. Crypto, in fact, is only used for the Oracle dialect in Connect.js. It's not needed for Postgres. FS, the file system package, that's only used to load a certificate file if we specify one as part of the connection string. And we don't need to do that because the certificates that are used by Neon can be validated against public root certificates, and they will be by default. And the stream package we don't need because we're not using streaming queries. So we can create a shims folder, and we can create sort of simple empty or stub packages for these. So let's do that now. I'm going to create a shims folder, and just cheat a very little bit. I've already created those shim packages to save a little bit of typing while you're all waiting for me here. So crypto, fs, and stream, and I'm going to copy them into the shims folder. And you'll see that in each case there's just a package.json and a JavaScript file. The package.json has the name and a description, and the JavaScript file is literally just an empty object. So we are just trying to silence any import complaints here because we know that these packages are never going to be used. This is not going to be a problem. And then finally, there are 2 packages left that make up the third category, and those are packages that we do need to create a simple shim for. And those packages are timers and tty. Now, one of Connex's dependencies is called tarn, and for some reason tarn imports clear interval from the timers package, even though it uses set interval as an ordinary global. And so to keep everyone happy here, we can create a shim package that just re-exports the clear interval global as a timers package. And I'll copy that one in now. Again, if we look at that, it's a simple package JSON, and the implementation literally just exports the global clear interval as a clear interval object inside the timers package. And then tty, the final package that we're missing, another one of Connex's dependencies is called colorette, and that's used to print nice colored terminal output. And before it does that, it checks whether it's printing to a terminal rather than some other file or pipe using the tty package. And so all we need to do here we can just rig up the relevant function to always return false, to say this is not a TTY. That will not get us in any trouble because it won't be a TTY in the cases that we're thinking about. And so again, here's my simple shim TTY package. Just give it the name and a description in package.json, and then the implementation is simply that single function is a TTY that's called by colorette, and we just return false. Having done all of that, we then need to add all these stub or shim packages to the package.json file. So if we find the dependencies here, we can see the ones that we already installed on npm, but we need to add the others that we've copied across. So for crypto, do this, hopefully spelling it right. For fs, we do the same. Just two more left. We need to do timers. Again, these are all these local path packages that start with a file protocol. That's timers rather than timer. And lastly, TTY. So I'm going to save that. I think that all looks correct. Having done all of that, then we need to make sure that they get installed. So I come back to the terminal and I type npm install now. And with that done, we should find that this now just works. So let's try npm versal dev. That runs the esbuild build command, and then should have this work in a browser for us. Okay, I'm going to copy that URL. And now that'll be not found because, of course, what we are looking for is the index file in the API folder. Having a think, and there we go. So we're returning some entries from the employees table. This is a very literary company, so we have 3 writers as our employees here, and so we've made that work. So I hope that's been useful to you. That about wraps it up for today. I wish you luck running in JavaScript packages everywhere, not just in Node, but in browsers, on serverless platforms, and beyond. Thank you.
Hi, I'm Sam Ibar, Developer Advocate with PolyScale. Today I'm going to discuss how you can get more out of your Neon database by adding PolyScale's AI-driven cache to your architecture. In just minutes, literally, you can be caching all of your cacheable queries, leading to faster query response times and reduced load on your database, while giving you low latency global access to your data. Before I dive in, let me give you a brief overview of what I will cover today. What is a DDN? What is PolyScale? PolyScale and Neon architecture overview, creating a PolyScale cache, and using Neon with PolyScale. At the end of this talk, you should have a good understanding of how you can get more out of your Neon database by combining it with PolyScale. What is a DDN? A data delivery network, or DDN, is a term that we at PolyScale use to describe our overall database acceleration platform. PolyScale's DDN provides improved query performance, expanded connectivity, easy access, and scale to your database data. Think of a content delivery network, but for your data. You can easily connect any type of application to your database via PolyScale in any location, including monoliths, serverless functions, and edge functions, all while maintaining global data consistency. What is PolyScale? PolyScale is a high-performance data delivery network, DDN, that accelerates databases. At the core of PolyScale's DDN is a distributed, fully autonomous cache engine. This is deployed across multiple locations and cloud providers, forming a global edge network. PolyScale is wire protocol compatible with Postgres, as well as several other databases, which means it can be plugged into your existing application with only a change to the connection string. PolyScale then analyzes all of the traffic that passes between the application and the database, identifying what queries are candidates for caching, It builds statistical models on every query and defines how long the data should be cached for. As part of its global edge network, PolyScale has proxies that sit between your application and your database. Your database queries are routed to the PolyScale POP closest to your application, resulting in sub-millisecond response times for cached queries, regardless of where your application and database are located. PolyScale also has a self-hosted option, so you can deploy it within your own VPC in the cloud or on-premise as your needs require. Let's talk a little bit more about how PolyScale works. PolyScale uses AI to determine which queries can be cached and how long they should be cached for. Because PolyScale is wire protocol compatible with your database, we are able to parse the queries and intelligently set and adjust appropriate TTLs for read queries based on a number of inputs, such as the arrival rate of your queries and the frequency of change detected in the underlying data. If you pass all of your write traffic through PolyScale as well, we will automatically invalidate the cache when writes are made that impact cache data. If you cannot pass all write data through PolyScale, you can connect a CDC stream to PolyScale to notify the cache of database changes. While PolyScale provides automated caching, with PolyScale you also have the option to manually decide to cache or not cache specific queries or tables and to manually set TTLs rather than use PolyScale's AI. PolyScale's global edge network spans Amazon, Google Cloud, Azure, DigitalOcean, and Fly.io. You can run an application in multiple locations or even on multiple networks and still get sub-millisecond latency for cached queries to your application with global invalidations. In addition, PolyScale significantly reduces the load on your database. Every query served from cache is one less query your database must serve. We've seen customers be able to cut their database spend by over 75% due to reduced load. So summing up, what are the benefits of PolyScale? Sub-millisecond cached query responses, resource and cost efficiency, less load on the database, and easy implementation allow you to save money. Reduced network latency. Because PolyScale has a global network, meaning wherever your application may run, you can get sub-millisecond response times. Unified data access. With PolyScale, you can access your data via TCP, or you can use our HTTP API from locations like Vercel Edge Functions and Cloudflare workers, or anywhere where a TCP connection might not be the optimal solution. Simplified scale engineering. Because PolyScale is so simple to implement and can provide massive concurrent responses, your application is prepared to scale from day one. Future-proof performance. Because all of the queries from your application run through PolyScale, we are able to provide caching for every query you may have in your application, whether it's one you already have today or one you may build for a feature in the future. Now let's talk a little bit about the architecture of PolyScale with Neon. As discussed before, PolyScale sits between your application and your Neon database. So if you have a Neon database hosted in Virginia with an application running on AWS Virginia, your application will use PolyScale's AWS Virginia POP and get sub-millisecond cached query responses. If you're using multiple Neon branches, you can create separate PolyScale caches for each branch. Because PolyScale has a serverless pricing model, you pay only for what you use, so there's no barrier to setting up an additional cache for each branch. PolyScale has an API you can use to create and destroy caches as well. So if you create and destroy branches as part of the build process, you can create and destroy caches to go with them. Let's take a sample application that has 90% reads and an 80% cache hit rate and a mix of fast and slow queries. With this application and PolyScale, you could reduce load on your database by 72% and reduce average read query response times by 80 milliseconds simply by plugging in PolyScale. As noted, PolyScale also supports multi-region and multi-cloud setups by routing queries to the POP nearest your application wherever it may be. So suppose you added an additional instance of your application, this time running on Google Cloud Singapore. You could connect that application instance to the same PolyScale cache. With an application with similar characteristics as described on the slide above, you can again cut load on your database by 72%, and in this case cut average read query response times by 270 milliseconds. Beyond multi-region and multi-cloud applications, PolyScale also provides support for HTTPS access to your database through our HTTP serverless API, as well as our self-hosted solution, which allows you to install PolyScale within your VPC or in your own location. Before we do a quick demonstration, let's just summarize the savings PolyScale can provide. First, we provide savings on infrastructure due to lower database usage and therefore database cost. Second, we provide savings on developer cost due to the ease of implementing PolyScale, which means no rewriting application code and no need to spend time figuring out TTLs and invalidations. Finally, we save on opportunity cost. Because your developers aren't spending time writing caching code and solving slow queries, they can be spending time bringing new features for your application to market. Now we'll begin the demonstration part of today's talk. The first thing we're going to do is demonstrate how to create a PolyScale cache for our Neon database. For this example, I have a Neon database hosted in US East 1 in Virginia. Creating a cache is very simple. All we need to do is copy our host name from Neon, and then when we go to PolyScale, we click New Cache. We give the cache a name, select a database type, which is Postgres for Neon, paste in our database host, the port, which is 5432, and go ahead and click Create. We've now created a PolyScale cache which is ready for use. If we'd like, we can run a network test, which will ensure that our database is accessible from PolyScale's edge location. We can see here that all of the locations on PolyScale's network were able to access our database. We can also run a performance test where we can compare response times for queries direct to the database versus cached results via PolyScale. To do this, we simply input the username for our database. We put in our database password, our database name, and we can run a query. In this case, we'll just do a select one. We can then choose where to run the queries from. In this case, for now, we'll run them from US East, where our database is hosted. What we'd expect to see here is that response times are about the same because it's a simple query running from the same location as our database. And sure enough, we find that direct to the database, the query is returned in about 2 milliseconds. And via PolyScale, we can see we've got miss here and then hits, but all are as fast or faster than even that simple query, even though we're in the same location. Now, if we were to do a comparison from a further location, let's say instead, let's do Singapore, Google Cloud. If we run this test, what we'll see now is that the requests direct to the database are much slower because they're having to traverse a great distance, whereas the request to PolyScale should be quite fast as we're returning from our local POP in Singapore. So again, here you see direct to the database, we had query response times of 218 milliseconds, whereas our queries direct to the database were all in this sub-millisecond range. So with that, we've now created our PolyScale cache. The next step is to use it in conjunction with our database. In order to do that, we'll simply update our connection string that we use in our application to replace our host with PS Edge Global and append our PolyScale cache ID as an application name parameter to the connection string. So let's go ahead and copy this cache ID, and let's go ahead and go to our application. So here what I have is just a simple application that will connect to our database and make the same request 25 times and show us the response time for each query. This application runs a query that takes some time, so we can see that our database doesn't necessarily respond that quickly. So let's go ahead and run this query. Let's go ahead and run this, and we can see that the query we're running here is just select count star as employee count, max salary as max salary, min salary as min salary from salaries. There's quite a lot of records in this database, and what we see is that the average query took 193 milliseconds. We can use the same application to actually put some more load on our database. So we can run 4 of these queries in parallel, 4 of these series in parallel. And so when we do that, what we'll see here now is that the response times have actually increased. So where before, when our database wasn't facing much load, these queries had response times in a sub 200 millisecond range, we're now seeing response times increase into the 400 to 500 millisecond range. Now, to introduce PolyScale, all we need to do is update our environment variable. So we can replace our host name with psedge.global, and then we just add the application name parameter, like so, and we're good to go. Now we can run the same application again, and what we'll see is the first couple queries are slow, but then they're much faster. PolyScale is intelligently figuring out what the optimal TTL for caching these queries is, and if we run this again, what you'll notice is that the time between misses, which are these slower queries, begins to increase. And as PolyScale gets smarter and smarter, it will find the optimal time for the TTL for these database. So you can see our average time is now reduced, in this case, to 15.4 milliseconds. Now, if we were to run these queries in parallel with PolyScale, again, what we'll see is that we still get sub 1 to 2 millisecond queries from cache, and while the average times are skewed by the misses, we're still getting much faster response times, even though we're putting a lot more load from our application. The database itself isn't seeing that load at all. If we return to PolyScale now, what we can see here is we can go to the observability panel within PolyScale, and here we can see exactly the queries we've run, and we can see that we've run 275 queries, 244 of which were hits, which means that this is all load that we removed from our database because we've introduced a PolyScale cache. We can also get other insights from here, like we can see, for example, the average execution time for cached queries versus uncached queries. And so we could look at all of the different queries that we're running to our database to identify which were slow queries and which were faster queries. As I mentioned before, PolyScale also gives you the ability to set TTLs for specific queries. So if, for example, we didn't want to cache this query, we could go ahead and, from within PolyScale, set a rule and manually specify that we didn't want this query to cache at all. So if we set a TTL of 0 for this, for example, and go ahead and submit that, and we now go back to our application and run the query again, what we'll see is that all of the queries are slow because we're no longer caching it. So we really have the power to decide what we want to do. Alternatively, we could extend the TTL here, and we could say, I'd like to have a TTL of 10 minutes. And now when I run this query, we can see that we get hits all of the time. Now, if we were to go to a different location in the world to run queries, without PolyScale, what we would see is a dramatic slowdown in the response times for our database. So here's another instance of this same application that is running in Singapore on Google Cloud. So if I run this same query again, right, when I run directly to the database, you can see that my response times are now actually quite slow. and even slower than before because we've got the distance to the database. But if I were to now plug in PolyScale instead, so let's replace our connection string with the PolyScale connection string, and I were to start running this, we see that our query response times quickly get to the 1 to 2 millisecond range. And since we've set a long TTL, they're automatically caching. Now, one question you may be wondering about is what happens if you were to have updates to the underlying data and you have a long TTL set. So we can demonstrate that as well. Here I have a application that's going to just loop through and make this slow query over and over again. Again, we're getting these still very fast response times because of the caching in our database. What I can do though is now if I were to grab this connection string and connect directly to the database, or connect to the database via PolyScale from my local machine here. And what I'm going to do now is I'm going to update this database and what we'll see is when I make that update, you'll notice that PolyScale automatically invalidated the data. And again, if I were to make a similar query again, PolyScale will immediately invalidate it. And again, we can see how even though these updates are happening where I am in New York, PolyScale is immediately updating our POP in Asia. So what have we just done? In a matter of minutes, we've taken our Neon database and added a PolyScale cache that we can plug into our application by simply updating the connection string. Our PolyScale cache gives us much lower latency, both for queries to the database locally that normally would take longer, as well as for queries globally to the database. In addition, it relieves load on the database, allowing you to get more out of your Neon database. Thanks for tuning in today to learn more about how to get the most out of Neon with PolyScale's data delivery network. Thanks.
Hi there. Really excited to talk to you from Coherence as part of Neon's Developer Days. I'm Zach Zarrow. I'm the co-founder and CEO here at Coherence, and these are some of the companies I've worked at. And today we're going to talk about the future of development environments, how Coherence can help you supercharge your development team's velocity and productivity, and how Neon and other kinds of futuristic serverless tools can help with that as well. Ultimately, we believe that it's a really exciting time in software development and in infrastructure and platform engineering in particular. The future of infrastructure is here. Things we dreamed about 10 years ago are reality today, from serverless to deployment tooling and automation, integrations, and just in general knowledge of best practices. It's a really exciting time to be working. Talk a little bit about the past and present in order to get to the future. We really believe that development environment has become an overloaded term. There are three important uses that we commonly see about it. One is the development environment on your laptop. The second is a pre-production sandbox type account that developers throw broken code at, or maybe broken code at.
and then talk about with their team on Slack or Hangouts or Zoom, to question what parts are usable of all the various services and applications deployed to these environments, and sometimes automatically tracking a branch like dev or a trunk or integration branch like main. For our purposes, we want to define development a little bit differently and sort of talk at a high level about three different types of environments. One is what we just talked about, development environment. This means something on your laptop. Second is a pre-production cloud deployment. So this would be things like full stack branch previews, which Coherence is especially good at delivering, especially in conjunction with tools like Neon. But things like staging or demo environments would also categorize here. And then last is production, which is a important different type of environment because it has different characteristics. So developer environments generally used by one developer in order to run and test changes to the deployment in that environment with as fast a feedback loop as possible. So like a hot reloading dev server is the common use case here, and you want to be able to see the impact of what you changed without having to go through CI/CD, right? That's like the key point of a development environment and how we're going to define them for the future, even if it's not how you talk about it today. A pre-production environment, which what some people call dev environments, would categorize here, is a deployment of the application that is used by different kinds of stakeholders to review and test the application before it's released to production, which is the third category here. So things like branch preview environments, staging environments, QA environments, the different stakeholders might use different ones of these in terms of like branch previews being used more by end-to-end testing and devs as they're working on things, staging QA being used for more integrations and business stakeholder, product manager testing. There's really no reason it has to be that way, but this is often how it is. And some of the environments often called dev really are generally what we would call these pre-production integration environments. And then prod, right? You've got your real environments, usually just one, sometimes more than one. If demo environments are really important for customer sales use cases or customer deployments are part of the application you're working on. And really this is about the data, uptime, stability, compliance. It's going to be monitored and used most heavily generally of the environment types we've talked about. So like, what does the future look like if those are the kinds of environments we're going to talk about and that's sort of the state of the world? I think these are the characteristics of the future of dev environments that we see emerging in the market and sort of at the cutting edge of developer experience. Ephemeral, these things are easy to create and destroy. That means they have to be reproducible, so they come up in a known state and you don't have to spend your time debugging them. They should conform to the SDLC and controls that the other kinds of environments do. If dev is too different, you're going to get bugs when you ship it to testing environments or production. They should be flexible, so you should be able to use them in different ways for different members of your team to work in the way that works for them and do their job. They should be compliant, so you shouldn't be able to have a production data incident because your development environments can't work as well as they need to. Integrated into the rest of your ecosystem, right? Like it shouldn't be a big deal to promote something from dev into a production environment to test it, or a pre-production environment to test it. And they need to be accessible, right? They have to meet developers where they are. If you can only access them in really limited ways, then you're going to end up finding developers find a way around the environments you've created and make their own environments that don't meet all these characteristics. So at Coherence, we have something called Workspaces, which is a cloud IDE similar to GitPod or GitHub Codespaces that are integrated into the full stack SDLC that we make it easy for your platform team to deliver or help you deliver even if you don't have a platform team. Things like full stack branch previews, automated infra as code, deployments into your own cloud account, including things like integration testing, and meet a lot of the characteristics we talk about for pre-production and dev environments, including things like reproducibility, reuse of database seeding or snapshotting or Neon branching as is relevant today. And we make it really easy for you to just throw a Neon API key at Coherence, and as you make branch environments, automatically get corresponding database branches for your Postgres environments. And we think that serverless, auto scaling, easy to create nature with a really seamless integration you don't have to write a lot of scripting around is something that is going to be a game changer for teams as they expose their developers to this and really expose them to a higher level of velocity, and accessible in context in the same UI with the right configuration without having to reinvent the wheel and be consistent across services and applications, because you can use the same platform for a lot of different applications at your company or across different projects. And that's what the future looks like. You got to get your hands on it to really feel it. A lot of these are the characteristics. Are they fast? Is it easy to pair with other humans or AI agents? Are they easy to use in cloud heavy configurations where you're using a lot of integrated cloud services like AWS or even other serverless tools? And IAM roles, is the tooling your team's using make it easy to support them? We hope it does. Let us know what you think. Feel free to reach out to us, hello@withcoherence, and tell us what your view on this is. So thanks for listening.
Hello, how's everyone doing? This is Simran Hanswal, technical evangelist and AI engineer at Hasura. Have you guys ever asked your folks for books recommendation and realized they have recommended books that they've read and liked and not what you may like? Ever wondered how amazing it would be to have a system that can recommend books to you based on your mood? Well, I built one for you. And today I'm going to talk to you about how I built a smart book recommendation with PG Vector on Neon and Hasura in very little time. So let's get started. What are the ingredients? Well, the ingredients are large language model, a collection of books data, and most importantly, you need RAG. RAG what? Large language models are great, but they're frozen in time and cannot solve tasks on data it hasn't seen before. One of the ways to expose the unseen data to large language model is by providing the context related to the question. This helps the LLM to generate more accurate and grounded answers. In this case, recommend books that actually exist and not make up one. This powerful technique is called retrieval augmented generation, or RAG in short. So you see, we need to build a RAG pipeline for our books recommendation use case. We also need to make sure that our RAG pipeline is production ready. Building data API already takes up a lot of our time. Building dynamic data API, it takes the challenges to next level. So let me show you how I built this really cool application in no time. Let's get started. To get started, first we'll have to head over to the Hasura console and create our database. And I'm not going to be doing this because I already have a Neon database available, but in case you don't have one and you're just getting started, you can always scroll down and click this yellow button to get yourself a free cloud Postgres database. I have this already, so I'm not going to do that. Next, we will move to Neon's dashboard and collect this connection string. We're going to be using this for a bunch of stuff because we're going to be running few queries on Postgres terminal. Right. Another prerequisite is Hasura Notebook. Hasura Notebooks are cloud-hosted notebooks that not only let you experiment quickly, but it also enables you to create dev endpoints so that you can prototype really fast with Hasura. It enables you to iterate fast. We also have a bunch of pre-built project templates so that you can play around with them. The way you get started is you use Hasura CLI to execute this notebook create command. Once you do that, you are provided with a URL. You can head to that URL, and the first thing that you will see is a dashboard like this. You can launch the notebook, start, stop, restart your endpoints that you're serving from your notebooks. And let's get started with the data part first. Right. So like I mentioned before, we will need the connection string to use the PSQL. The first thing that we will have to do in order for us to use the PG vector is to enable the vector extension. The next thing that you will see is that we have two tables. One for the books, which has all of the data related to the books, and the second one is for the embeddings. This is where we are storing our vector embedding. Now, you can use any embedding model of your choice, but I have used OpenAI's ADA embedding, which is of size 1536. You will also notice that we have two functions. Now, this is required because vector is a new data type and it is not supported on Hasura at the moment. So we have to build a workaround for that. And the way we do that is we treat the vectors as text strings and Hasura. So while calling any of the Hasura APIs, these are strings, but when you actually execute it at the level of DB, we typecast it. So the first function that we have is for the insertion needs, where we take the embeddings and we insert it into the table. And the second function that we have, sorry about that. And the second function that we have is for the retrieval part, where given an embedding, we look up similar or related results and we return the best results. Right. So we are ready with our schema. And so you can almost say that we are ready to get started with loading the data. Right. And I would say we are ready to load the data, but we are not ready to do the multiple or duplicate effort. So if you remember, we have the books table and also the books embedding table. I don't want to write to two tables twice. It's some amount of effort. So I want to reduce that. And what we're going to do is use Hasura's capability of events trigger to optimize this. And what we're going to do here is that as and when a new record or a new book gets added into the books table, I'm going to auto vectorize that and add that to my books embedding. So let me take you to this notebook, which has all of the endpoints. First thing first, the way you set up endpoints is by defining this comment. So here you're defined that this is an endpoint with the name handle event. And what we are doing in this event is that whenever a request comes in, we are processing it with the business logic, which in this case is to take the description, get the embedding out of it, and call the first function that I showed you, which does the insertion or the writes into the table. Good. So now if you move onto the Hasura console, you'll see that I have two tables, the books and the books embedding. They're empty. The first thing that we're going to do here is set up an event trigger. I'm not going to do that again because it's already set up, but I'll walk you guys through it. So define event trigger name, what's the source, books, schema, and where is it going. So this request is going to be handled by this webhook, and this is nothing but the URL of my notebook. I just had to suffix it with invoke, and then it's the endpoint that I defined in my notebook, which is this, and the URL is this part. It's just the same, nothing else. And we will also have to define the authorization because this endpoint is coming from an authorized notebook. Great. So once our event trigger is set up, you saw that our data is not, there's no data in the system yet. So we have some insert queries. We will execute this. It looks like it has executed. We will head back to our data and you'll see that not only did we get the books, but we also got the vectorized data. Amazing. So now that we are ready with our data, now we can head to building a recommendation system. So the way we are building this recommendation system is by using a capability of context retrieval and augmenting that context to the LLM, as I told you. So in this case, we are taking the user query that is coming in, generating an embedding out of that, and fetching relevant books that becomes the context to our LLM. And our LLM is assigned a very specific task, very specific personality, and a very specific task to answer the user's question with a list of books. So it's got to recommend a book and also explain why. What additionally we are doing is we are taking our results and formatting that for our prompt. Now, if we go back to our actions, I have already defined this business logic here. Defined it as a recommendation query, which takes a string input and returns a string output. Again, I've defined the webhook where this business logic resides, which is nothing but the URL of my notebook and also the endpoint that I defined for that business logic, which is this. What additionally I've done here is set a little, really extremely large, but you can set something more reasonable as a timeout because LLMs are slow in processing and generating responses. So it might be good to have a decent timeout set for your application. So now let's head over to API where we have all of this information, and I'm going to ask for a recommendation. I'm going to say that, let's say I am traveling to Singapore. Sorry about that. Singapore next week. I want a thriller read for my travel. Let's see. There you go. So we have some recommendation. It says that for thrilling read to take on your travel, it recommends a book, and it's a perfect read to keep you on the edge while you explore the city. Amazing. That sounds like a really good recommendation. So I think we're good to go on a vacation. So that's it from me. Thank you. Thanks everyone.